And the schedule is so you make introductions and then Lisa goes and I go.
Dr. Gupta, it's hard to hear you. I'm not sure if you're not close enough to the mic or not.
Can you hear now?
Yes, that's better.
I see. So what's the schedule? So you start off, you make introductions and then.
Yes, and Rajesh, the people can hear us now. They just can't interact with us. So at about 8:03 to 8:05, all will start it off officially, and then I'm going to introduce you, and I'm going to introduce Dean Ordonez as well.
Okay, and then who is speaking after that?
And then we go to the corporate panel.
Uh-huh.
So Scott Zoldi is going to run that corporate panel, and then after that corporate panel, Kyle is going to moderate the series of lightning talks. And then after the lightning talks, our keynote speaker.
I see. Okay, no problem.
So for those of you listening, we're going to get started here in just a couple of minutes. I see one of our panelists just jumped on the main screen. Chris, how are you? Just realized his video was on and switched off. So Dr. Gupta, it looks like we're all set for maybe September in person again. Does that seem to be the timeline?
Yes.
Okay.
That's right. Yeah. The default is we come back to campus.
Well, I know our talent director, Emma, is waiting to get back on campus. We've, since we're not on campus, Tech San Diego, obviously no one is. We've had to be pretty creative about how we, build interaction and engagement with students. And one of the ways we've done that, and it's been very, very successful, and including Data Science Day, is working with the student clubs. So we've been working with a whole host of student clubs to make sure that we keep them connected to the local community. We want to make sure, as the students matriculate through the system, that they choose San Diego as their ultimate career destination. It's a much better place to be than some of the other tech regions. So part of what we do is just expose them to the companies that are here in town, which is sometimes challenging because, we don't have a lot of these big Fortune 500 companies. We certainly have a few, but we're a small, medium-sized tech town, and there's lots of great companies. So we're going to get going here in just about a minute or so. So thank you for attending. We're just making some small talk before the introductions and before we get started. So welcome to Data Science Day. It couldn't get here quick enough. Let's see, make sure I have my. Thank you for registering. We're going to start here in just about a minute. Just making some small talk before the official event starts.
You're doing a good job, Kevin.
All right. I know there's going to be some folks. I know we have a lot of students sign up for the event, and they'll be coming in and coming out as time goes by. So let's go ahead and get started. Officially Data Science Day. So good news. So first of all, let me introduce myself. I'm Kevin Carroll. I'm the Executive Director of Tech San Diego. We're a nonprofit association that supports the regional technology community. For those of you unfamiliar with Tech San Diego, please visit our website at techsandiego.org. Tech San Diego has a number of initiatives to support the regional data science community. We have 2 program series, the Teradata Distinguished Data Science Speaker Series and the Cooley AI Machine Learning Trends Event Series. We also have a data science roundtable and a number of other activities to support the regional cluster. Our goal is to help the regional tech community recruit and retain data science talent. Data Science Day shines a spotlight on the regional data science community and highlights the region as a data science center of excellence. So before I start with the introductions, let me go through some of the logistics of how you can ask questions or ask chat. There is a question box. We will be monitoring the questions. Participants are unable to they can see and they hear us, but they're not going to be able to interact, so you interact through the questions. There's also a chat function as well. Rely on the questions. If there's something really pressing, you can go ahead and use the chat functions, and that's how kind of the logistics will work. We would not be able, let me start some of the formal introductions. So we would not be able to do Data Science Day without our partners, UCSD, HDSI, and the Rady School of Management. They have been instrumental in helping to plan Data Science Day, and they highlight the importance of creating data scientists. Without them, we would not be doing as well as a region. They're really creating the future pipeline. So let me start out by introducing Rajesh Gupta. Rajesh Gupta serves as director of the Halicioglu Data Science Institute and as a distinguished professor of computer science and engineering at UC San Diego. Professor Gupta's research is in embedded and cyber physical systems with a focus on sensor data organization and its use in optimization and analytics. Professor Gupta received the Bachelor of Technology in Electrical Engineering from IIT Kanpur, India, a Master of Science in EECS from University of California, Berkeley, and a PhD in Electrical Engineering from Stanford University. Dr. Gupta is a fellow of the IEEE, the ACM, and the American Association for the Advancement of Science. And perhaps more importantly, he's also a board member for Tech San Diego. Dr. Gupta?
Thank you, Kevin. Thank you for inviting me. Good to see you, Dean Ordonez. This group is very close to my heart from the earliest days of Tech San Diego. Kevin, you were instrumental in having the community of companies organize and support what was then an idea, and that was the idea of a data science major. And you wrote the support letters. Those letters were part of the approval process, and they are now in the foundational documents of data science program and Halicioglu Data Science Institute. So I'm very happy to be here. After 1 year of on Zoom and alternatives, I cannot tell you how anxious I am to actually be in person. And hopefully we will get there by fall. HDSI is now in the second stage of a rocket that we launched 3 years ago. We started out by taking the hardest problem first, and that was creating an undergraduate program. In fact, we made it student-centered for one reason and one reason alone. The core architecture of HDSI was to make it a student-centered institution that would produce the most compelling talent in the area as it emerges in data science. Of course, as an institute, the institute also defines the area. But the hardest challenge, and one that is usually taken last by most organizations of our kind, was to create a educational program, and that to an undergraduate educational program. That requires the highest level of scrutiny and highest levels of thinking in terms of a program that will be in place. I'm happy to say we are about to graduate our second cohort of data scientists. First cohort was about 70 students last year, and looking at their employment and where they have gone, it has been just very heartwarming. And the other day I posted on LinkedIn their positions and where they are going. In my entire career, that was the highest shared post ever. So when I come to now, today, with 200 plus, more like 240 students graduating this year. We are creating a talent pool that is already beginning to be part of the industry, both in San Diego region as well as nationally. Now, when we look at it, we have now, with this talent pool, also gotten quite a bit of feedback as to what subjects we're teaching and how we're teaching them and what impact they're having in industry. We have also launched and we have gotten approval from UCSD Campus Senate, and now it is a system-wide for a Master's of Science and PhD in data science programs. We expect both of them will be launched later this year. And more exciting than that, we have also received approval from the campus, among the very first ones, for a completely online Master's of Data Science program that is also at the system-wide. So in the coming year, there will be 3 new programs coming up, all graduate nature. And most heartwarming to me is the cooperation and collaboration we have had with Rady School on a new program that we are expected to launch. We will be doing a trial run on a 4+1 program where Bachelor's of Data Science is followed by a Master's of Business Analytics or Master's of Finance as a pathway. A program that saves the students 1 full year and over $20,000 in savings. Because the way the units such as HDSI work so closely with the Rady School of Management. So Dean Ordonez, thank you very much for your leadership and the very first down payment on what would be a long collaboration that I look forward to. But I said that this is a rocket that is not yet in an orbit. And what I mean is that once you have the institutional programs in place, then you turn your attention to the intellectual challenges of the field itself. Those challenges are addressed by researchers. I'm very happy to inform you that in 3 years, we have now 26 faculty members who are appointed within HDSI. 14 of them actually have been full-time appointees. Yes, so these researchers are now beginning to ask questions as to how learning happens, how brain functions, how do we understand nature, what kind of data analytics gives insight, how do we match models, and so on, to data. And that research is the second phase of HDSI, which is building a compelling research program with PhD students and postdoc programs that are now coming online. So with that second phase of the rocket, we hope to find a stable orbit in 2 years when we have both academic and research programs are in place. And hopefully by that time, HDSI, which is now located in multiple facilities across the campus, we are so proud of having found home in so many hearts. But we'll probably have a place of its own as well, simply because the size has become too much for anyone to accommodate us. So with all that coming online, the part that we have been we started on the day 1 of the HDSI launching was our industry license program, and that license program now run by Eric Neon has quite a few of your members actually part of our program, and every quarter we meet. I think we have a meeting coming up later this month as well. So this has been a journey for us together. Kevin, we produce talent. We rely on your feedback, your engagement to tell us if we are getting things right and where do we need to go in the long term. And I hope this partnership thrives in future as HDSI finds its orbit and really creates these programs. The online program, for example, is one of many. Similarly, 4+1 program that is coming up with Rady School is also hopefully a start of what the university can do when they work closely with our industry partners. With that, thank you for inviting me. I'm looking forward to the program. I see on the program we have a number of new faculty members who are from HDSI who are joining your panels and talks. I look forward to hearing from them. Thank you.
Thank you, Dr. Gupta. And I still remember being in your office. Geez, it must have been probably 4 or 5 years ago, and you were sketching out what your vision of the Data Science Institute. And as you sketched it out, I told you it looked like an octopus, and it would never fly through the UCSD bureaucracy. And so, geez, it's just really truly amazing how you've created this very unique kind of interdisciplinary program, one of the global leaders in data science. So congratulations on doing exactly what you had envisioned almost 5 years ago. With that, I am going to introduce Dean Ordonez, another one of our partners. From the very beginning of our data science efforts, Rady has been a critical part of that. Dr. Ordonez became the Dean of Rady School of Management at UC San Diego in 2019. Dean Ordonez applies her operational skills in leading the school, building on a strong foundation led by founding Dean Robert Sullivan. As the second Dean, she attends transition Rady from a startup to focus on growth and further cementing the school's global business research prominence and impact as an innovation-focused economic engine within the San Diego business community and beyond. Previously, Dean Ordonez was a professor in the Department of Management and Organizations and Marketing in the Eller College at the University of Arizona since 1994 and served as vice dean from 2015 to 2019. She received all of her degrees at UC Berkeley, a bachelor's in psychology, master's in marketing, and her PhD in quantitative psychology. And I think, geez, I could probably keep on reading from Dean Ordonez's bio, but why don't I turn it over to Dean Ordonez and let her say a few words.
Thank you, Kevin, and thank you, Rajesh. We're just as excited about our partnership with you. So good morning. It's a pleasure for me to represent the Rady School of Management and be part of the edition of Data Science Day. The Rady School of Management has always supported our regional data science community. You see data science stakeholders and students, and we're committed to keeping our region as a data science center of excellence. We believe that the Rady School of Management has a critical role in this space, and we will show a few examples later on in the lightning talks where our faculty will provide an excellent spotlight for your data science research. I'm very proud of the Master of Science in Business Analytics degree at the Rady School. This STEM designated program provides our students the required skills to succeed in data-rich business environments. The program offers rigorous hands-on training that prepares our students to use data and analytics to identify business opportunities, generate insights, and create value for customers and companies. Now, executives can enroll in our Flex Weekend Mba program that will be launching this fall. This program is made for working professionals who are asked to provide business recommendations and make critical decisions with analytics and data. Our curriculum is made to ensure that all master's graduates can use machine learning and statistics to solve business problems in the real world. And in fact, we are actually designing an exec ed program for those who don't necessarily want the full degree, but need to understand business analytics deeply enough to be able to deploy all these new data science and business analytic majors that are being hired in the region and beyond. Many of your companies have hired our students and participated in our capstone projects, and we're grateful for trusting us and helping our students and alumni experience the entire life cycle of a business analytics project. And before I leave you today, I want to acknowledge our students, corporate partners, and benefactors. Thanks to you, we were named one of the top 50 best value big data graduate programs and the first ranking of our program 4 years ago. We're still the only graduate business analytics degree in San Diego. And Rady's connections to the business world is a significant asset for graduates entering today's job market. So once again, thank you Tech San Diego and our friends at HDSI for allowing us to be part of this annual event.
Thank you, Dean Ordonez. Just once again, the purpose of Data Science Day is to really shine a spotlight on the regional data science community. We couldn't do that without involving UCSD, HDSI, and the Rady School. It really gives us a competitive advantage in a global marketplace for talent, which is the new economic development is really all about talent. And so our thanks to both of you and the entire UCSD system for recognizing that and being responsive to the regional data science community. So with that, we're going to go on. We're going to go on to the panel. So those of you that are speakers that are not talking can now go off camera and on mute. So Dr. Gupta and Dr. Ordonez, you can go off camera. I'm sure you'll be lurking to listen to the panelists and the lightning talks, but we'll go on. I'm going to introduce we're going to get going with the first panelist. I'm going to introduce the sponsor for the first panel. So the sponsor for the first panel is Teradata, and representing Teradata is actually a quite familiar face, Brandon Quach. Brandon, if you can come on screen, I see you there. Brandon is chair of Tech San Diego's Data Science Roundtable and has been an important advisor to Tech San Diego on Data Science Day, and in fact, our entire portfolio of initiatives around data science. I was glad Teradata sent you as a representative. So I'm going to turn it over to Brandon, who'll say a few words about Teradata and introduce the moderator for the panels. Brandon, it's all yours.
Okay, thank you so much, Kevin. Now, Kevin, are you able to see my presentation here?
Yes.
The slides? Okay, and does it look like the whole screen is filled just with the slide? Perfect. All right. So thanks so much, everybody. Thank you, Kevin, for having Teradata sponsor this panel. I just want to say a few words about us as a company. Okay, who is Teradata? Well, we transform how businesses work and live through the power of data. We started in 1979, actually, quite a long time ago, and we had a SQL engine, one of the most powerful SQL engines in the world. And since then, we've built up this tech stack so that we can take in more sources of data, such as Avro and native object store. And we've also built layers on top of our engine, which now you can interact with SQL, Python, R, etc. And of course, these days we are in the cloud. We work in Google Cloud, AWS, Microsoft, and also our internal cloud. So now we call ourselves the Connected Multi-Cloud Data Platform for Enterprise Analytics. And how do we do that? Of course, with the great people that we have currently and the great people that we like to recruit from schools such as UCSD. We have a saying within the company called Rise as One, where the way that it applies to my team is that we take the data engineers, the business process analysts, and the software engineers and combine them with the data scientists so that when we do our work, we know it goes into production and has meaningful business impact. So with that, I would now like to introduce our first speaker. So I'm going to stop sharing my screen here. Okay, our first speaker for today is Scott Zoldi. Hey, Scott, how are you doing?
Brandon, I'm good. How are you?
Good, Scott. I'm just going to say a few words about you and then hand it off to you.
Okay.
So I've introduced Scott a few times here, so let's see if I can do it better this time. Scott Zoldi is the Chief Analytics Officer at Fico, responsible for the analytic development of Fico's product and technology solutions. While at Fico, Scott is responsible for authoring. Now, Scott, we always change this number every time because it keeps getting bigger and bigger, right? So what I see on my screen, 105. Do we got an update on that?
It's a little bit bigger, but that's close enough.
All right, more than 105 analytic patents, everybody. Scott is actively involved in development of new analytic products and big data analytic applications, many of which leverage new streaming analytic innovations such as adaptive analytics, collaborative profiling, and self-calibrating analytics. Scott has most recently focused on applications of streaming self-learning analytics and real-time detection of cybersecurity threats. So Scott serves on two boards. He's the board of directors of Software San Diego and also Cyber Center of Excellence. And in terms of educational background, received his PhD in theoretical and computational physics from Duke University. So always a pleasure to hear from Scott. I'll let you take it away.
Great, thank you, Brandon. So it's a pleasure to be here today, and it's a pleasure for us to talk about the topic of how San Diego data science is changing the world. many of you have been at these events in the past, and we understand the critical role that San Diego has played with respect to data science. We have many founding companies that are leaders in the data science field, and in partnership with UCSD, really spawned off companies such as the one that I started with here in San Diego, HNC Software, which has been one of the founding companies. And today it's a pleasure to just look back, right? I've been in San Diego for about 22 years, focused on data science. And during those 22 years, I hope that myself and the colleagues that I've worked with over the years have really changed the world. And I think one of the things that we're going to talk about today is how San Diego is continuing to change the world. And I have 3 different data scientists that are going to be speaking with us. They're going to do presentations so that we get to know them and their companies and how they are attempting to change the world with data science. So as we look at how San Diego data science is changing the world, we'll hear from 3 companies. We're going to have Chris from Chromacode, Joost from Dexcom, and Nik from Viasat. And they'll talk about what they're doing, how they're using machine learning. And afterwards, we're going to ask questions, right? And I'm going to invite each of you, if you have questions, to post them in the question panel. I'll try to queue those up, make sure that they get asked. I'll also probably have a few of my own. So I'm looking forward to this being a good dialogue with plenty of questions as we kind of focus on the newer use cases of data science and machine learning across San Diego today. With that, I'd like to turn it over to Chris so he can start his presentation.
Great, thank you so much, Scott, for the intro and passing it over. And so I will go ahead and get started if we are all ready to go. My name is Chris McDonald. I'm the Vice President of Engineering, Operations, and Data Science at Chromacode Incorporated. We're a diagnostics company. Molecular diagnostics is probably a little bit easier to explain now than it was about 1.5 years ago. If you think about what we do is PCR. I think at this point, probably most people in the world have heard of PCR, and you've probably used PCR in the last year or so related to COVID testing. Branded qPCR, for a long time, it has been what's called the gold standard in molecular testing performance. qPCR essentially looks for these trace nucleic acids or DNA or RNA that is present in a sample. So for example, in the case of a COVID test that you may have taken, we would be looking for the genes that are part of that virus, the SARS coronavirus 2. And then looking for the presence of that and trying to call, if there's presence of that in a particular sample to help guide a patient's knowledge. One of the big things that's happened in the last year or so is there has been a significant expansion in capacity in qPCR, as you all know. Similar to maybe what we would analogize, the expansion of the US railways in 1870 or optical fiber in 2001, all of a sudden now there is a lot of capacity for this qPCR testing, and we live in that space and are trying to be able to use it to help patients and clinicians, doctors, hospitals drive decisions about their populations. If you think about what we do as far as data science in a diagnostics field, it's really not that much different. It's the same models that you might use in any particular way. If you're trying to classify whether a particular picture is a cat or a dog, you might use some deep neural network to classify what's going on and then make a decision when you see a new sample as to what the state might be. It's generally in the life sciences, just like in many other places, it's observational. So, you have your kind of canonical data science steps here on this chart. You decide what you're going to do. You acquire this problem, you extract the features, generate a model, and then you go use that model, whether you're trying to classify a cat, classifying some type of either cancerous cells, pathological cells, or something else as it may be. And again, very typical in industry, right? If you don't make the correct classification, if I thought that cat was a dog, then I could potentially go back and get more data. So if I go back and I get pictures of thousands and thousands of cats and dogs, I apply a learning model, I refine my model, I do some more work, and then I get back and I get a better solution. So this is the approach a lot of people take. You may or may not have heard of the company Grail. Grail is a cancer detecting startup, and what they're looking for is trace amounts of DNA that are related to mutations that might drive cancer in a body so that you can get an early look at what might be going on, or an early look and find stage 1 cancer incredibly early. They're doing a great job, but if you look here, one of the key parts of the headline that I put over here is that they raised over $900 million to go get that data. Big data, the company with the most data has an edge. That is not the case for us. We're a small startup in Carlsbad. And so we've had to do things a little bit differently, and we utilize some of the tools of data science in a little bit different of a way. So instead of trying to go back and get more data, what if you asked a different kind of question? What happens if you could create the source data? So instead of going back and looking for thousands and thousands more pictures of cats and dogs, you could enforce that every single cat had a picture of a green hat on it, just as far as a cartoon model. So in this case, you're talking about actual literal feature engineering as opposed to the data science side, which of course in real life is going to be quite difficult. So self-driving cars probably can't, take advantage of this as far as enforcing, all pedestrians wear certain items of clothing or things like that. But on the plus side, we can. So one of the things about, the life sciences, molecular diagnostics, is that we create the actual chemistry that creates the signals that we're trying to read. So PCR, as you've heard, is sensitive and cheap DNA detection, and there's a lot of components that go into that. So the idea is that we create a chemistry that combines the actual DNA or RNA sample you're trying to read, polymerases, enzymes, primers, probes, nucleotides, different components, and it goes through a machine that creates an exponential amplification of the target. That particular target, and what happens when you actually do that PCR reaction, if something's present, is you get something that looks like this. So any PCR test you've ever done looks a lot like this. So you have some component, some liquid in a tube, and you heat and you cool it, and eventually you start creating an exponential amplification of that DNA and a fluorescent signal that gets red out of it. And eventually that levels off. So if I see this exponential amplification, I might know, for example, a sample has coronavirus that's present in it. An observation that you might be able to make, though, is that, on this data, as an example, on this particular PCR instrument, you read in a lot of scientific data. You read 60 floating point measurements. The answer, though, is just, does it have coronavirus or not? Yes or no. So if you think about it from more of an information theory standpoint, thinking of like Shannon information theory, and really the fundamentals of what data and information are, you're only really extracting one bit of information from this biochemical system. Is this sample present or is it not present? Whereas we actually read in quite a bit more data than that. So what we do at Chromacode then is we use some of the tools in data science and the observations about the chemistry that we have to take and engineer that curve and engineer the chemistry to be able to encode more than just that one target, encode more information. So given that the chemistry components dictate that curve shape, the process is one of actual biochemistry development guided by the data that we generate in order to maximize the separation of the different signals. So in a very literal sense then, going back a few more slides, this is truly feature engineering. It's using the chemistry to engineer as independent and orthogonal features as we possibly can that make the data science and the classification on the backside essentially a trivial problem if you do it right on the chemistry side, so that you can encode more information into a reaction. What that means, and the upshot of it, is a couple of things. We have this chemistry and this test that can encode information about a patient or a sample, and we can use that to learn more things. So imagine it's 2025 and you go to the doctor or you go check into urgent care because you have a fever. Well, you're not going to want to go in and get a flu test, right? Coronavirus is still going to be around at some level, so you're going to want to check for coronavirus. But you're also going to want an answer to what you have, right? Could it be flu? Could it be coronavirus, respiratory syncytial virus? There's a whole host of different possibilities that might come out of there. And so what we do is we want to be able to give you an answer when you come out from the doctor, as opposed to, oh, it wasn't coronavirus, sorry, I'm not sure. So the idea of using the data science to compress more information into the chemistry itself is really the core of what Chromacode is about. And then, so we have a developed roadmap. The idea is that we can expand this capability to any PCR system across across the country or the world. And so the idea here is that you'll start to be able to see and get more clinical answers, more data for any patient or any doctor that needs to identify what's actually happening in a particular patient or in a particular population. We deliver this via the cloud. So one of the nice things here is that we develop reagent kits, we sell them to customers, they use it, then they can analyze the data that gets generated into Chromacode Cloud. And so what that is then we can deploy across many instruments, we can deploy virtually into these labs. So we train people on Zoom, they run our chemistry, it all gets analyzed in the cloud. So it's very easy for someone to take up and use a new test. And then it allows us to also understand and help with what's going on. So we're able to aggregate this data across the population and look at epidemiology in particular areas and help understand what's going on in a particular population, whether there's an increase or decrease in positivity rate, viral load, things like that might be able to tell you if there's some rise of some particular strain variant or other things that might be a problem, even down to the level of a university site is kind of where we'd like to get to. So I guess to summarize really all of this, I think the interesting approach and maybe the interesting thought to take away from this is data science can be a lot of things. And one of the things it can do is actually on the chemistry side, if you have a diagnostic or life science tool, it can actually allow you to take control of that data structuring, which could allow fundamentally new applications on existing tools. Either these respiratory panels that I mentioned, enabling non-invasive prenatal screening without costly and slow sequencing. So if you want to know, from trace amounts of DNA in the blood if your baby's okay. If you want to do early and easy and fast oncology testing that allows you to guide drug treatment, these are a lot of areas that we're very interested in, and we think we're going to be able to contribute to. A lot of this and a lot of the roadmap, especially on the respiratory panels, has led us to a lot of recognition and a lot of ability to support testing throughout the US in the past year. This approach that allows us essentially to upgrade the amount of information in existing reaction, as well as deploy quickly, also led us to win the COVID Testing X Prize competition for fast, frequent, cheap, and easy testing and help a lot of folks out during the pandemic. So we're really excited about this. We're excited about the approach that we have for data science, the things it can do, and hopefully it's a little bit of a different perspective than you see at a lot of different use cases, because fundamentally we can actually control that input data. All right, that's all I got. Thanks, folks. I'll pass it back to Scott.
Thank you, Chris. Super interesting. We'll have time for questions. I mean, obviously, tremendously sort of timely and of great relevance given all that we're suffering with through the pandemic. So with that, thank you for the introduction. I'd like to go now to Joost from Dexcom, so he can take us through his use case in terms of how data science is helping the world through Dexcom. Welcome, Joost.
All right, thanks, Scott. My screen coming through okay here. I will get started. So thanks, Scott. Thanks to the organizers as well for putting this day together. My name is Joost van der Linden, and I'm a staff data scientist at Dexcom. And I'm going to talk about how data science is helping Dexcom change the world, specifically about ways in which we empower our patients and our Dexcom teams to both see and understand our data in various ways and to decide and act with confidence, supported by our data-driven insights. Overall, I'll show a subset of the data science and analytics applications that are relevant to us. Certainly, that's not meant to be exhaustive, but nonetheless applicable probably to other contexts too. So to start, since folks might not be familiar with Dexcom and the reality of living with diabetes, I'll start with a quick introduction there. So our mission at Dexcom is to empower people to take control of diabetes. And the reality of living with diabetes is that patients are essentially in charge of managing their glucose levels because the pancreas is not working properly. And the most important data point in doing so is the glucose value, which traditionally is determined using finger sticking, pricking your finger and using a blood glucose meter as illustrated on the slide here. 4 values were measured in this example that I put up here, mostly within that glucose range of 70 to 180 milligrams per deciliter that you want to be in. But a lot can happen between these readings. For example, what if the green line was the actual glucose trend? There were periods here above 180, and even more importantly is that there were unnoticed periods of low glucose, which patients want to avoid. And this is where those continuous glucose monitoring products that Dexcom makes come into play. So patients wear this sensor on their body, is shown on the bottom right, and that connects via Bluetooth to a device like your phone. And this enables patients to see their blood glucose levels in real time every 5 minutes, generating 2 orders of magnitude more glucose data compared to that finger sticking approach. And this empowers people with diabetes to take action quickly with insulin or with food or otherwise if glucose levels are too low or too high. So data has really been at the center of our mission from the very beginning, and data science plays an important role here, both in helping patients leverage their data to make the best decisions and improving our products as Dexcom grows as a company. And there's more. What you see here on the left is the Dexcom G6 app corresponding to our most recent generation of sensors. We also have the ability for patients to share glucose data with up to 10 friends or family or caregivers by the Share and Follow apps. And this feature is especially appreciated by parents and caregivers who can track glucose for their loved ones and receive notifications about hyper and hypoglycemia, specified thresholds and intervals. I read a story recently on Instagram just the other day from a user called Andrea, whose son Jack loves to play baseball. Those late night practices have him go low at night and into the next day, and Share and Follow really helps her out in situations like this. And she said she can't imagine managing this disease without Dexcom Follow, and I thought that was a great everyday story from one of our Follow users. Lastly, Dexcom Clarity is our weapon app-based software that empowers both patients to view their glucose data retrospectively over the last 30 days, for example, highlighting trends, patterns, statistics in a range of reports that can be shared. And then healthcare providers also use it to review their patients' CGM data, their glucose data, remotely to help make diabetes management decisions. So having introduced Dexcom here in the remainder of the presentation, I want to focus on some of the actual work we do as data scientists. And going back to that introduction, I'll split that up in 2 parts. For each part, I'll just focus on one example, given time, starting with the kind of question answering work that many data science and analytics teams deal with on a day-to-day basis. But the application I wanted to highlight in this talk is the one with more external visibility, and that's for us around demonstrating the value of CGM to our patients and the insurance companies and government bodies and other organizations that will often pay for our products. Because long-term prior studies have shown the benefits of continuous glucose monitoring for improved glucose control, especially compared to the traditional approach of finger sticking. And certainly, I don't expect you to read everything on the slide here. The point I want to make is that we already have published and presented a lot of correlational studies showing similar results to this headline based on our own real-world evidence from what are now over 900,000 users globally within governance and private data privacy boundaries. And we continue to do so in the data science team, focusing on things like the benefit of using Share Follow and the app I introduced earlier that allows users to share their data with caregivers. We do population health studies too, recently to assess the impact of the COVID-19 pandemic. We use some of this work in marketing materials to make claims. And in all of this, we're aiming, as I said, not just to show the benefit to patients and healthcare providers, but also to the insurance companies and the government bodies that cover our technology, especially as we expand internationally. And throughout all of this, our data science team makes a difference with the ability to process really large volumes of glucose data and other data, creating engaging visualizations and telling data-driven stories. And both with the internal work that we do, this question answering work we do for internal Dexcom teams like sales and marketing, and this external work that we do showing the value of Dexcom CGM, I think we have what is a really interesting opportunity to increase that value proposition even further beyond correlation by thinking about causation, to demonstrate the value of existing products and product features, and to use it to build new ones. And that brings me to the second part here, and that is the work we do to empower patients and Dexcom teams to decide and to act. And for patients, I already alluded to it at the start, we're really focused on helping patients leverage their data to make the best decisions. And a great example of that, handled in our company by a more specialized analytics group called Algorithm Engineering, is the Urgent Low Soon Alarm. That's a predictive algorithm to predict if a patient will go low, below 55 in the next 20 minutes or so, suggesting action to mitigate the impending risk of low glucose levels. For Dexcom teams, decision-making with data is part of our culture, and we support many teams this way. Regardless of whether we're doing this work for our patients or for Dexcom teams or other stakeholders, we see causality, as I alluded to earlier, as an exciting opportunity to bring our work to the next level. And I wanted to use my last slide here to discuss that. When folks talk about data science changing the world, you'll often hear machine learning was one of the first things mentioned, and certainly it has had a really major impact in applications, and just heard a great one from Chris here. But if you ask me where data science and statistics really can change the world, then I think causal inference is at the very least a key ingredient to make a difference, and perhaps sometimes a bit overlooked. If you're not familiar, I wanted to do there's a tiny bit of an introduction here, a quick simplified diagram of one of the main techniques to infer causality, and that's a randomized experiment in which you split up a sample of end users in two groups. You get a treatment group and a control group at the bottom. And the control group is identical in all ways, if properly randomized, to the treatment group, except for the fact that the control group does not receive the treatment. And if done properly, then you can compare outcome variables of interest at the end and derive causal insights. And these causal insights are the kind of holy grail of decision making, in my opinion, because to predict whether something will have an effect, you want to know if it causes an impact, or if you're just dealing with a correlation and there's underlying effects that might explain your relationship. And good businesses don't act at random, I read in a blog post by Emily Riederick, and I think that sums it up really well. And this idea of causal inference, though, it certainly does not come without challenges. The one takeaway I wanted to share with you today on the technical side of these challenges as a data scientist is that while randomized experiments, the ones I illustrated before, may be difficult to design and run, and we certainly know all about that as a medical device company, they're not the only vehicle to infer causality. There's a lot of other techniques that have been developed over the years with certain assumptions that allow you to draw causal or neo-causal conclusions. Quasi-randomized experiments or natural experiments or regression discontinuities are great examples of opportunities we may encounter without designing an experiment that we encounter naturally that will still allow us to infer causality in certain situations. And if an experiment isn't perfectly randomized, or if the treatment isn't exactly what you want to measure the impact of, then there's certain techniques for that too. And it takes time, it doesn't always work, but as an investment in data science, I think it is one that is important to consider. Beyond the technical challenges, there's much more. There's governance and compliance and regulations to adhere to, data privacy boundaries, the ethics of running randomized experiments, and more. They're all challenging areas, but we're excited to work on these and solve these problems. in all of this, the final point I wanted to make is that data science cannot and should not change the world by itself. So both in causal inference and everything else I talked about before, it should be cross-disciplinary work, and machine learning is a good example here, I think, where taking that approach can mitigate for some of the risks like model bias. And regardless of whether we are informing our patients or we're informing our Dexcom teams, helping our Dexcom teams as data scientists, I think we should provide recommendations and make decisions together. And with that, I would like to thank you for your attention. My email address is shown on the slide here for any follow-up, and pass it back to you, Scott. Thanks. Yes,
thank you very much, and really interesting work there. Dexcom, I think that the causal sort of aspect of this is really important as we look at how to use data science and how to make the right sort of decisions. So I'm looking forward to diving into that a little bit more. Okay, so then let's do our third company here, Viasat. Nik will speak to us about the company and also about the work that they're doing in terms of data science and how San Diego companies are changing the world.
Okay, let's make sure I can share my webcam and you can see my screen, yes? All right. And can you see my screen and can you hear me?
Oh, we can.
Okay, great. Yeah, thank you. All right, so I'll go ahead and start by introducing myself. My name is Nik. I started at Viasat about 17 and a half years ago or so as a software engineer. And over time, my career is just sort of morphed. The through line through my career and all my roles has been to keep Viasat amazing at software and now data science and machine learning, and to get Viasat to be known to be amazing at this stuff. So I really appreciate the opportunity to be here with you today. So what is Viasat? We are a global communications company that believes everyone and everything can be connected. And so I'll talk a little bit more about that and why that can be so impactful. Viasat has already designed, developed, launched, and we currently operate the world's most advanced broadband communication satellites. We are about to dwarf our existing global capacity with our new constellation called Viasat 3. This is 3 geosynchronous satellites that are flying around the Earth in geosynchronous orbit around 23,000 miles up in space. For comparison, the International Space Station is only 250 miles up. So in addition to the satellites, we also design all of the technology that lives on the ground, antennas, modems, dishes, encryption devices, and all the cloud-based software infrastructure that powers our network. So that's just a glimpse of our cutting-edge technology. The key thing is, what do we do with it? So today, we provide residential broadband internet service for the underserved and unserved markets in US, Europe, and a few countries in Latin America. This is one of our customers in a rural town of Mississippi who we featured on our Instagram. Because our most expensive capital infrastructure is in space, we can deliver bandwidth anywhere on Earth without needing the same kind of massive investment that cable and fiber companies need to make. And for millions of people, these companies simply choose not to make the investment for them. And I'm not knocking on cable and fiber companies. I'm actually one of their customers, and I'm supposing all of you are too. But these companies can only be successful when there's enough people living close enough together with enough money to justify them digging the trenches and laying fiber to the neighborhoods and homes with any hope of recouping their investment. And so during the past year, we actually saw a dramatic increase to our residential subscriber business. And this was almost entirely due to COVID and the need for families to have broadband connectivity for remote schooling and work. People tend to stay with a service provider until it breaks for them. So something about their needs change and their current provider just can't perform. And so a lot of people switched to us from DSL and other technologies because the pandemic changed their connectivity needs and only we could meet them where they were. And so we're not just innovating in technology, but in business models as well. We have provided broadband connectivity to thousands of remote towns and villages in Mexico and Brazil. There are so many emotional, impactful stories from these people, and I'll just relay a couple. I heard of children who can actually take a 45-minute bus ride home from school instead of choosing to spend the night at school so that they can use the internet there for their studies and homework. I also heard stories of displaced Central American refugees who made it to one of our connected schools that was serving as a refugee camp in Brazil, And these people were able to connect with family back home with FaceTime and other communications technologies to reassure that their loved ones that they're actually still safe and alive. So when we first ran experiments with connecting a few remote villages in northern Mexico, we were surprised to discover that there was almost as many devices as there were people. It turns out that everybody already had a phone, but they could only use it when they made a long commute to the nearest city. And Viasat for many years has already operated a global satellite network for the maritime industry. So when I'm working from my boat instead of from my guest bedroom closets, I'm still connected. The same global network has provided the world's best in-flight connectivity for business and private jets too. So I'm still connected even when I'm on one of mine. And when you fly, you can use our best internet service too. I love this picture because the passenger has a seatback infotainment system available, but he's using his own tablet to stream Netflix. And no longer are you limited to whatever movies and shows your airline offers in these systems. You can just watch whatever streaming services you already subscribe to. And I'm sure your AirPods will work better than the headphone jack in your armrest. Despite COVID essentially stopping all commercial airline flights for the better part of a year, which was a big hit to our revenues, we are really excited about the future of this business and our current position as the global leader. Last month alone, April 2021, there were over 106,000 commercial air flights connected with Viasat service. On those flights, there were approximately 9 million devices that downloaded 636 terabytes of data in the air. Some of our airline partners include airlines in the US, such as JetBlue, United, American Airlines, and Delta, and we have many international partner airlines like KLM, Scandinavian, Qantas, Aeromexico, and more. So sometimes I get on Twitter or Instagram and I look for people who are tweeting about our service. The picture on our left I included because it should warm all of our hearts. Here's somebody with a Jupyter notebook open on her laptop, 35,000 feet in the air, traveling 500 miles an hour, and still finding the time to do data science. There's one more US airline I forgot to mention. There's a story I heard, but I can't confirm, is that somebody at Viasat got word to President Obama's senior staff that the kid watching SpongeBob on his iPad, sitting in the middle seat in the back row next to the restrooms, had more bandwidth to his iPad than all of Air Force One did. And JetBlue gave it to that kid for free. So now we're the in-flight connectivity partner for Air Force One and the rest of the blue and white senior leader US government fleet. So that gives the president the ability to have a true situation room in the sky, and for a few years there, even more access to Twitter. Speaking of government, I haven't even mentioned that there's a whole other side of Viasat's business, providing secure, reliable, resilient communication systems for US and allied governments and militaries. So if anyone here is or knows a veteran, you know better than most how important assured communications and situational awareness is for the safety of our troops and the success of their missions. Now take a look at this photo. Normally, if this was in an interactive panel type thing, I would ask the audience if anyone can guess where it is, but I'll just tell you. This is actually a coastal town in New Jersey that was devastated by Hurricane Sandy. This was a town that before the storm had great internet service available. Now they don't even have land to stand on after the storm. The Red Cross and other humanitarian organizations around the world have used our technology to provide connectivity and connections between first responders and to set up Wi-Fi hotspots for families who are devastated by these storms to be able to connect with their loved ones and find help for themselves. So that's what we do, and I think it's pretty world-changing and changing for the good. So where does all the data science fit in? Well, our mission is to connect the world. So we use data to learn about people, or to put it bluntly, where's our markets and our potential markets? Where do people live? How many are there? What are the economic demographics? What, if any, competition exists in these locations? How does this inform what business models might work in these areas? We also use data to monitor and measure network performance in our subscriber experience. So in the upper right, I'm hoping you see an animation. One of the side effects of geosynchronous satellites is that we have a roughly 600 millisecond round-trip latency. What that means is when you visit, say, ESPN.com in your web browser, your request is beamed from your house 23,000 miles away to our satellite and then back down to Earth to hit up our backbone network where we connect to ESPN servers. And then ESPN's response has to go back up to the satellite and back down to your house. And most web pages are actually pretty empty, with most of the content being pulled from other sources. So the actual ESPN homepage might be, go fetch this JavaScript, and then that'll say, go fetch that JavaScript, and then go get this banner ad, and go get this content, and go get this image. So all of that happens in a serial manner. So what we did is we built a machine learning powered browser that learns how web pages work and predicts what you will request next. And so we just prefetch all the stuff that we think you're likely to want next based on what you're requesting now. And the result is that for our internet subscribers, that web pages pretty much fully appear immediately as compared to normal browsers over our network. And I mentioned in-flight internet before. So we use data to learn about flights, right? How are flights happening right now? How are they doing? The animation you hopefully see on the left is from another internal tool we developed, providing visualizations of commercial aircraft on the globe. You should be able to see airplanes taxiing on the runway, taking off, and flying around. And we can move around the Earth just like you'd be able to move around with Google Earth. And then we look to the future, not just what's happening now or what happened in the past. Where do we predict flights will be in the future? How many flights will there be and where? What times of day will they fly? How many people will be flying and how much demand for bandwidth will all these people on these flights generate? It's analysis like this and predictions that inform how we design our satellites and what we say illuminate the Earth with capacity. Where do we put capacity and how much? And obviously we don't just do that for airlines. We use data to imagine, model, and predict all sorts of things about the future. We build internal tools that model all sorts of satellite systems, and we use data to analyze potential markets and understand their unique constraints all around the world. There's an ever-increasing demand for bandwidth. Just think about your own personal sort of internet progression. It used to be, I watch TV mostly and I watch YouTube sometimes. Then that became, I stream Netflix movies every once in a while, to I fully cut the cord with my cable company and all my media is delivered over the top with my internet service. And very quickly, that's going to be, now I want everything in 4K all the time. So data is increasingly at the center of how we strategize for the future, how we measure the present, and how we learn from the past. Thank you very much for listening.
Thank you, Nick. I appreciate that. You know, as somebody that unfortunately or fortunately have used those Wi-Fi services on almost every flight I've been on, you know, they work amazingly well, right? Maybe too well in terms of doing data science and not being able to watch the in-flight movie. But a fascinating sort of need, and I think, you know, particularly with the fact that you're serving the underserved, right? It's really critically important in terms of ensuring that areas like poverty are better addressed, right? In terms of access to education, access to services, it's a critical human need. And in addition to, you know, ensuring that executives and people are getting work done on their flights, a really important problem. So thank you for that. Okay, so I'd like everybody, also Joost and Chris, to come back onto video. And what we want to do now is open this up to questions from our audience. There is a questions tab here, and I will do my best, and Sarah will help me if I'm not doing a great job at monitoring the questions that come in and ask them. I'm also I prepared a few questions myself as I've listened, hopefully representative of maybe different things that some of you may have observed or thought about. And so I'll start there. I'll ask a couple of my questions first. My first question, I guess I'll ask one to each of you. And Chris, you know, thinking about Chromacode and thinking about the fact that you really focus on, you know, feature engineering, right? And there's a big sort of science around this concept of, you know, one shot or multiple shot learning, right? And I think it's really important. So I wanted to get your thoughts around this from two aspects. I mean, one aspect is, you know, small data is actually tremendously important if you understand what you're looking for. And I think that's one of the key things that you're focused on, right? Is to simulate or understand exactly the signal that you're trying to find, understand the mess that it's going to be in from a complexity perspective, and refine algorithms to go look for that. And so I'm a big fan of small data versus big data, and it's a little contrarian to, you know, a lot of data scientists today that get enamored with very large deep learning systems and huge amounts of data. So I'm a big believer in that. The question I have for you, though, is, you know, around synthetic data and how best to create those signals. And I'll give you an example from some of the work we did way back, right? When we entered, like, let's say, fraud detection models in a new country, right? We would say, well, the fraud primarily occurs through this type of customer, right? And if you're not careful in designing the model appropriately, what you detect is that type of customer, not actually the signal. So as an example, if you're going to a new country and the consumers in those countries tend to be the wealthy that get to travel a lot, and that's where most of the fraud occurs, then you end up building a wealthy traveler model, not necessarily a fraud model. And so there's a lot of kind of challenges with respect to creation of synthetic data. And I actually think it's one of the new domains of data science that we really all will be focused on in the near future. So I wanted to get your thoughts around, the feature engineering, but also, the care and feeding we need to do with respect to the generation of these synthetic examples to train on.
That's a great question. I think that there's probably a fairly nuanced answer there, right? Because it's obviously dependent on whatever the subject area you're doing, right? And I think one of our corporate advisors is Yasser Abu Mustafa, who wrote kind of the Learning with Data textbook, right? And does the edX machine learning course. And one of the big things that he talks about, right, is, regardless of how many samples you train on, regardless of what you're doing, right? You train your sample and you have some boundary, say some parameter region that you've trained that model on. And if you move outside of that, right, the answers are going to be unpredictable, whether you've done 1 sample or 10 samples or 100 samples, right? So the big thing I think to start with for us is really understanding what the bounds are of the problem and what the parameters are of the situation you might be looking for. In the case of PCR specifically, there's only certain ways that curve can go, because you have this chemistry that is driving those kinetics, and those kinetics are modelable by fairly simple differential equations, right? So you can create some boundaries on what the ranges, even the most extreme sides of what those signals might be, and ensure that you're able to test that range. In our case, the key there is the collaboration with the subject matter experts, right? Where you work with chemists, biochemists who understand the subject very well. You understand what are the kind of outer bounds of the different situations you might see. And then that helps you understand, can I be comfortable with a couple of signals or a lot of signals, or can I model out a synthetic signal and set of distributions, right? I know that this is normally distributed. I know that this is that, right? And then the other piece, of course, for us, right, is looking back at the cloud data that we do get, right? We have millions now of samples of data from the pandemic that help us understand what are those extreme situations, and we can use those to model in synthetic, distributions, right? Use, not just normal distributions, but the actual distributions of the data that we see as far as the different features that we might see in the curves. So it's a combination for us, and I think for us, it's more like going everywhere that you can possibly get for information about the system to help you constrain it, because we can't get a billion pictures of what we're trying to do, right? You also fundamentally with chemistry can't, sometimes there are just things that you can't measure about your system because it's quite small and difficult. And so kind of using subject matter experts as well as much real world data as you can to help bound that system. Then when you go in with your simulations, you understand the parameters you're dealing with.
Got it. Yeah, no, great. It makes a lot of sense. And I think one of the trends also is this concept of confidence in the answer, right? And so being able to understand the bounds and maybe, give the prediction, right? But also say this is my level of confidence would allow from a diagnostics perspective to enable that person that receives that information to take that into consideration, right? So I think,
there's a lot of notions in kind of mathematical proofs as well, right? Where like sometimes you can't get to an answer, but you can say, I know that the answer is less than X, right? So if you can formally bound something and say it is within this, and if it's within this, then I know that I'm right or right enough or something, right? Then you can make the right judgments about the situation without perfect knowledge.
Agreed. Okay, thank you, Chris. Joost, I have a question for you. As I listened, right, one of the things that I think is, well, there's a bunch of questions I have there, but one of them is really around the concept of causation, right? And causation is one of these kind of, I think it's almost like nirvana, right? And it's something that we often have many conversations about because we operate so much in the data science world of machine learning that sometimes correlation is mistaken for causation, right? Or it's just causation is not even important, right? Because what's important is that we can show a lift curve and win a gaggle competition, right? But causation is tremendously important because we need to understand that the actions that we're taking actually are the right ones that change and influence a an outcome. So I'm glad you raised it, right? Because I think it talks very much to the responsibility that we all have to have with respect to our data science, machine learning, our models in general that raise or make recommendations. And so, you know, I think you raised some of the concerns with respect to how to collect this data, right? Obviously, you know, if you have the ability to provide me a good recommendation, withholding that and seeing whether or not I have an adverse sort of reaction to not taking, let's say, the low alert action is probably not that ethical. And so I was just curious, you know, as you look down that causal path, right, one of the things that came to me almost immediately is this concept of reject inference, right? So let's say, you know, maybe you alerted me, but I wasn't by my phone, right? And so I didn't take the alert, and you collect that information. And so is there an active strategy to try to understand in the app today and the data you're collecting whether I've actually taken an action? So if I'm that person that's doing the baseball practice or what have you, and you know, I get the little alert, do I put in, and again, I'm not, it shows my naivety in this area, right? Do I put in that I had a snack, right? And that snack improved my glucose levels and I had it 30 minutes after you recommended it? Or is that data not captured today? And so it makes it a little bit harder to understand who actually took an action and a recommendation and who didn't, which appears to me one way to address that causal sort of experimentation.
Yeah, okay, great question, Scott. So I certainly think that, to your point, this concept of causality is important in both managing diabetes and business alike, as I sort of tried to convey in my presentation. And in terms of what we collect, yes, our sensors certainly don't collect everything. There's a lot we don't know about our patients, and that is just the situation we have to live with. And it is something that we're always thinking about, always working on, in terms of seeing how we can combine different data sets, combine external sources to learn as much as we can and make our insights as useful as possible for the patient.
Yeah, okay. Well, I mean, I think it'd be great to look at, and you know, I'm sure you're all thinking about how to expand. I'll give you one little interesting factoid, right? We did some work on the Fico score. Obviously, you know, I work for Fico, and one of the things that the Fico score focus, you know, is well correlated. I won't say it's causal, but what it's correlated with, it may be causal, is whether or not you follow recommendations, right? So, you know, how you manage your credit obligations and how you manage your health, right, really goes back to responsibility and some core sort of aspect. And so I'm sure there's lots of ways that you can back into, you know, measuring who you think is, you know, very, very good with the program and taking recommendations versus not, but tremendously important for those that suffer with diabetes for sure. Okay, and then Nick, I have a question for you then. And then I'll go and look at the questions panel again. Everyone who please enter your questions in the panel. So Nick, you know, one of the things that as I listened to the talk, right, I had a few different things that went through my head, and one of those is the following. You know, Viasat is again, it's incredible, right? It's in many ways, like I'm still amazed. I've streamed stuff through your services, flying over, you know, over the Atlantic, over the Pacific, right? I jest, right, because I wish I actually didn't sometimes have access to my machine. I've had stewardesses and the stewards ask me to just put away the machine because they worried that I would, you know, work nonstop. But I think a question I have for you is, you know, it's a great service and it's really important, right? It kind of addresses the disparity and lack of access to broadband is one of the biggest challenges we have from a poverty perspective, education perspective. So the mission there is really, really important. My question is one around data privacy, right? So when I looked at the satellite and you know, able to track flights, you know, the cybersecurity person in me that you know, I start to focus on the fact, well, listen, you know, I have a login. If somebody wanted to figure out where Scott is flying today and how best to understand what part of the world he is in, right? You know, the same sort of tracking that you do of let's say, the bandwidth of sending the data back and forth to, let's say, a set of users on a particular plane, right? You know, you may say, well, how much does Scott as a user leverage, right? And you can potentially even get into very detailed profiling to say how much, what services will Scott want to fetch versus the general sort of consumer of the service. So I was just curious, you know, what is the focus on, you know, sort of data privacy and you know, with respect to kind of users using the service and where they are, right? And what flights they're on.
Oh, it's an excellent question, and I think you know, I'll start by talking about before we were running, you know, consumer retail services. You know, Viasat sort of cut its teeth in the early days building networking and crypto and security systems for government. And so like we grew up as a government communications and secure networking company. And so security and privacy are in our engineering DNA. And I think that in addition to just having a healthy corporate culture and an understanding for data privacy, you know, there's also a bunch of standards and policies with how you control PII, with how you can understand how systems, you know, your systems are working for a user, but at some, you know, once you authenticate a user and make sure that they're, you know, sort of they've paid for a service and that they have a service plan, like you don't even know who the user is anymore. You just know that a user has this particular set of capabilities that they're entitled to because of what service level that they've paid for or subscribed to. And that's how we treat everything. I mean, we're big into data privacy. We're, you know, internally, a lot of our data that's personally identifiable is treated very sensitively. We have tokenization. There's access controls in place to reduce to limit the scope of a potential insider threat. We do a lot of internal training. I just took, you know, yet again more data privacy training yesterday. So I would say it's a mix. I would say it's a mix of going above and beyond with the actual regulatory compliances, and just living and working in a culture where, like I said, we grew up very sensitive to cybersecurity, data privacy, because the nature of the threat of being insecure in running the world's most, you know, secure communications, you know, being able to create networks where you're running, you know, top secret and above data through secure tunnels through the open internet, you know, gives you a lot of healthy paranoia about how to protect data for people like you and me. And then everybody that works at Viasat is people like you and me. Like, we are also consumers who have been affected by data breaches and all that stuff. I mean, I've shopped at Target, you know, I could throw out more company names. And so I would say it's a mix. I would say it's a mix of policy and regulatory compliance, consistent training, culture of DNA, you know, sort of cultural DNA, and the fact that we empathize with our consumers because we've always been in the same boat as well.
Got it. Yeah, thank you, Nick. And you know, I enjoy Viasat's participation in a lot of the local cybersecurity efforts in San Diego also. So definitely a company that takes it very, very seriously. And I'm glad as a consumer that is the case, and I won't worry as much when I'm flying across the Atlantic or Pacific or what have you.
Yeah.
Okay. So then I'm going to go. We have a question, and then I'm going to I'll ask that question and ask each of you to respond. So the question is the following: what skills should undergraduates focus on to best position themselves for a data science career? And then I think it's well, let's start there. Let's just focus on the you know, what skills should we focus on if we wanted to be in the best position to work as a data scientist in your firms. Chris, would you like to start?
Yeah, sure. So, you know, in my case, right, you know, there's obviously a unicorn that is a biochemist, right, with a PhD level understanding as well as statistics and everything else, right, you know, but you're never going to find that, and especially coming out of undergrad, right? So, but the thing that I look for probably are two things, right? But the one word that sums it up to me is fundamentals. So if you have a good basic grasp of statistics, can you tell if two data distributions are different, right? And tell me why. Can you, you know, look up something, learn a new technique and go apply it? All those kinds of things are much more important than can you design a 27-layer neural network on some Kaggle competition, right? It's can you look at some new data set and infer why that might be different from another one, and then go and dive in and go talk to someone about why that might be, go figure it out and keep going, right? So really those basic fundamentals of just math, statistics, asking good questions and forming hypotheses are probably, for me, one of the key or most important things that I would look for.
Great, thank you. Joost, anything to add?
Yeah, no, I think Chris put that really well. I think fundamentals would also be top of the list for me, because often I've worked in a few different applications, different businesses, different industries. The tool set is often constant in that you can apply them in different areas, and you're just learning about the application as you go. So I think that's important, the statistics, the fundamentals. I would also say, I would add, not to underestimate the value of communication in data science and the need to collaborate with folks who have no technical background. So you really often I find myself often pitching and selling ideas within the company, then also pitching and selling the results, explaining technical concepts in an intuitive way. And I think data visualization is really important in that area to clear, minimal visualizations that quickly convey insights to folks who have a very busy agenda and only have 10 minutes to look at your results. So that would be one of my additions to what Chris said there.
Yeah, Joost, thank you. Yeah, communication is key. So I'm glad you brought that up. And I see Chris nodding. Nik, anything else to add?
Yeah, I'll say that there seems to be a couple of attributes that I think are more ingrained and they're harder to teach, and that's why you want to, what I love about HDSI is again, throughout the entire thread of the undergraduate curriculum, there's a culture of like, I want people with a bachelor's level of technical understanding, but the curiosity of like a 2-year-old, right? I want people to look at something and just ask why. Have that endlessly curious mindset, a drive to use the data to sort of like, confirm or deny whatever their preconceived notions are. And then to do it with the utmost of focus on ethics and integrity. And so there's in it, I think that these are things that if somebody doesn't come in with a natural sense of curiosity, being surrounded by people and seeing how they benefit and grow teams and enthusiasm and passion through a relentless drive to like seek the truth and to be able to open their minds when new information and new data comes in that might contradict a prior held belief, that's huge. And I think that needs to be as part of the fundamentals of what the mindset of a data scientist is, as a certain proficiency with statistics or Python or R or any of the open source software utilities that we use every day.
Excellent. Okay. And then, another question that came in was one that I think is important, right? And the question is essentially how much preparation can be done independently, all right? And what sort of skills require experience in a private sector setting? So, I think this is one that I've encountered with people that are looking to make an entry into the private sector, right? They ask, should I be taking this course? What should I be? Should I be learning better Java? Should I focus on Python, right? Because, as good as the programs are, right, different companies have different emphases on types of technologies or skill sets, right? And I think I'd say it's fair that many of us in the private sector have to take our new scientists and spend a lot of time training them, right? Whether they have their undergraduates or whether they're PhDs, right? There's just a lot of sort of knowledge that gets baked into the investments that companies make. So, for each of your areas, what would be the things that people could do independently, right? Not through coursework and not through, but through their own sort of initiative that might make them better aligned with the types of jobs that you may have and the responsibilities you have to make them good data scientists and productive ones in their firms. Chris, would you like to take that?
Yeah, and I think that maybe Nik displayed or talked about that innate curiosity, right? And so, if I'm looking at someone who has taken an online course of Python versus someone who went out and built their own Python, analysis of the, NCAA tournament, March Madness or something like that, right? Kind of the go in and just build something, right? Those people who are using Python, whether it's specifically Python, probably the best place to start, where most people use that, right? Learning that language, but then building something with it so that you mess up a lot and make a lot of mistakes. You didn't version control your code and you totally screwed that up, and then you should have actually done this, right? And kind of going through that process, right, is important, and you don't get that just from like a particular course, right? So whether it's specifically Python or not, I think just going out and building something is probably a really strong, good experience. And it might be, like I said, doing some online thing, or also getting involved in some research or something at your school as well.
Great. Yeah, no, doing something real. Yeah, and being able to talk about where it went wrong. I mean, we learn more from what the mistakes we make than the successes we have generally. Joost, anything to add in terms of independent work that I could do or others could do to be successful in your area?
Yeah, no, again, I think Chris put it really well there, and I'm going to sort of add the same thing again as in the last question. Writing about it, then you build something, write about it, and you can write about it in two ways. You can write about the results and what you found, and sort of imagine you have this audience in front of you that is not a data science audience, but a business audience, another kind of audience without technical backgrounds, or little technical backgrounds. And then also another good exercise that I would recommend there is to think about writing an article or a blog post or something, explaining your methodology in an intuitive way, like you're explain it to me like I'm 5, right? It's as simple as possible, as intuitive as possible. Think about visualizations. That's a good exercise with something you built, and to make sure that you understand those fundamentals really well.
Great. Yep, absolutely. And then Nick, anything else or?
Yeah, no, I just to say that I 1000% agree with what Chris and Joost already said.
Yeah. Okay. All right. Yeah. No.
I do have one thought that came to my mind is actually maybe the best thing that prepared me was not technical at all. I actually worked my way through college teaching SAT classes to like high school kids that were not interested in learning math. Like 3-4 nights a week, right? And sitting there and just talking and explaining things over and over again really was great practice, kind of lining up with what Joost is talking about, right? Practice communicating, even if it's not specifically data science.
Yeah. No, I've seen that in my own career, right? The ability to make concepts are really, really difficult, understandable, right? For an executive team, for someone that you're selling a product solution to a consumer, right? That wants to use that, and ensuring that those concepts are not mathematical or complex, but those concepts are understood almost at the at a level where you can feel them or taste them, right? That they become second nature, like our sense of touch, I think is a real skill, right? And those that can master that or get close to mastering that are those that are going to be effective, right? And we do a lot of surveys at Fico of CAOs and others across the field around what are some of the barriers, right? And I don't think it's a skill that, yes, to your point, Chris, if people focus on from day one, right, they may eventually get good at it when they get a lot of gray hair, because it's hard. And I think even the CAOs struggle with making sure their executive team understands what they're talking about, the importance of different topics and within the industry. So I think that's of critical importance, right? I think one of the most frustrating things that I've seen for data scientists is when they can't express their ideas or they don't see their ideas come into production, right? And so they spend years of energy, and they might be very much right, but they can't communicate it to a point where it's a level of comfort there. Okay, so let me pivot then to a few other questions I have, and in no particular order, but one of the things that strikes me, right, when I look at this, and this is for everyone to comment on as they feel best, is we've gone through what we call the AI winters, right? And as we all see value of machine learning and data science in our fields, right, and we're pretty dependent upon it as it is, right? The EU recently put out some regulation. The regulation is basically talking about the fact that certain types of machine learning and AI are high risk. And some of those high risk areas of AI usage are ones such as facial recognition and tracking. Credit risk, interestingly, also goes there, right? Because making a bad decision about credit risk could impact someone's entire financial course of their lives, right? So it's considered high risk. That legislation proposal is controversial to many, right? And so it's controversial in the fact that for example, the BBC put out an article that said that the EU is killing AI, right? And whereas the EU would basically say, listen, these are very, very serious sort of implications we're making with our AI and machine learning. We're impacting people's lives tremendously, and there has to be a level of seriousness taken to that. And so, I look at things like this, and I also look at our own, United States sort of policies, which have generally been try not to hurt anyone along the way, right? And now I'm being a little bit, loose with my interpretations here, but it's compared to the EU regulation, right? We're kind of highly unregulated in many areas of AI. So my question for you as people that are changing the world with data science and improving people's lives, and you see the value of it, what's your thoughts about the roles of regulation? I'm not specifically the EU regulation, but if you want to comment on that, I'm more than interested to hear your opinions. But the fact that, recently I heard a great quote, which is every fintech is a reg tech, meaning that reg and regulation and fintech or any kind of tech will kind of be tightly integrated. So what's your thoughts about the increasing trend on, making sure that the AI is very well governed and we can demonstrate that to our boards, but also to our clients and potentially to the governments and regulation that will be potentially increasingly applied to these AI and machine learning services that do good? Thoughts?
Yeah. So I guess it's a really interesting thing, and maybe Joost will have some similar things to say as me in that our diagnostic tests are already quite regulated, right? And so what we've seen is maybe a little bit of the opposite, is that in 2017 when we were starting up, you talk to FDA's like, no machine learning, get out of here, right? And now it's more like explain why it works, defend it, right, and things like that. So they're moving in a direction of trying to understand how they can allow AI in applications, right? And for us, it's a little bit easier because if we can use the machine learning to help us inform how we create the chemistry, then we can go validate that chemistry without machine learning, right? And so we can take that approach. But we've seen that. We've also seen that with the cloud, right? So patient information in the cloud, we are HIPAA compliant. There's a lot of questions about that. But in 2017, 2018, you would go to a hospital lab director and be like, hey, we have this cloud thing, blah, blah, blah. And they'd be like, oh, you know what? Our IT would never, ever let this stuff onto the cloud. This is going to be impossible, right? We go talk to the IT director, and IT director would say, actually, you know what? Half their stuff's already on the cloud. They just sort of don't know it yet, right? And so, there's a lot of, patient, information that's all evolving very quickly. And I think from what we've seen, it's actually gotten, a little bit easier over the last couple of years as, cloud adoption, machine learning for these different things, right, has been more adopted in the like FDA and healthcare space. So, there's got to be some middle ground, because the nice thing there, right, is that it lets you go out and deploy these solutions with confidence, right? If you've gone through this level of review, this regulation, then it's definitely something that gives people confidence in what you're doing in AI or machine learning. So there's definitely value there, right? The question is, how do you balance that from not getting overburdened? On the bio side, it's already fairly heavily developed, so you kind of know what you're getting into. But then a transition, right, and trying to make sure that there's some balanced level where it's not too much, I think is going to be pretty challenging in a lot of other areas.
Yep. Other comments?
Not much I can add, really, Chris. I think you put it really well. That balance is also in our minds on the safety aspect, which is super important, and definitely looking to get more guidance there from the FDA as they define and prescribe use of AI. And I think that's, for us, is front of mind, patient safety. So yeah, not much else I can add. That was really well put.
Yeah, and
right.
The only thing I'll add too is we're starting to see that the role of industry is not traditionally industry has been able to influence policy just through sort of like normal approaches to lobbying and shifting policy. And what we're seeing now is that only works up until a point. You really need to have trust and credibility with the general public as well. And I think what we're seeing more and more is business leaders are realizing that they need to also sort of win the hearts and minds of the general public and really make the case about how their products are benefiting their lives, and that there isn't some secret, ulterior, nefarious plan to exploit them. And I think that's just been a real struggle given the world that we live in over the last several years. And a couple of bad actors have like fantastically misused people's data and technologies to dramatic effect. And I think that when regulations come in, they're a correction or an overcorrection to the worst actors. And I think that there just needs to be a better way of holding bad actors accountable without stripping away the fundamental technology that's critical to deploying these sort of customized and personalized. When we think about AI and ML, what we're talking about is the future of sort of dynamically customizable and personalized services. Whether you talk about sort of personalized medicine, personalized anything else, you can't have any sort of personalization without understanding people, in mass and at the individual level. And so it's a tricky situation, and I think eventually there might be an overcorrection, or a correction or an overcorrection back to a comfortable middle ground where we can move forward.
Yeah, that's a good point. And one of the things that, and maybe we'll touch on this some more, is some of those bad actors have been some of the largest and most visible companies, right? So in some sense, you'd expect some of the best funded companies and the ones that are really driving, data science sometimes to not make such mistakes or repeated mistakes, and that doesn't help either, right? Because public perception would be if these 2 or 3 or 4 very well known data science or machine learning companies don't seem to have good policy around this, or are callous towards it, right? What about all the rest of the companies? And I do think that doesn't help, right? When from a public perception,
or the way that they're not the bad actor, but they release a capability that malicious actors are able to use their technology in a side effect way that they didn't understand. And there needs to be better internal accountability and controls to prevent the malicious use of their services, so that exploitation doesn't prevent us from being able to do things that are truly beneficial.
Got it. Yep, agreed. Okay, so I saw another question pop up, and it kind of went away, but I think it's a good question, and so I'll ask it. And the question is this: in your views, how, for somebody that's an undergraduate, right, and they're contemplating and making a real big contribution to a company, how many of you would recommend that they pursue a graduate degree? And I'll just say, as kind of a little bit of a dinosaur, right, that my advice has always been, get the graduate degree, right? I hire a lot of PhDs, and we do a lot of fundamental research, and I find that sometimes that the process of going through and getting the PhD is really important, because I think, to some of Chris's points, right, and others, right, it exposes that sort of innate curiosity, right? I mean, you tend to have to answer fundamental new questions that haven't been answered before, and therefore you think more deeply potentially, and you question the constructs around you. But I was curious of each of your vantage points on the, if you had an undergraduate that was bright and they had a great future career, would you say, listen, take some time out to go get that graduate degree, because we think that would be the better outcome for you in terms of some of these companies or your own specific company? So thoughts around that?
Yeah, I guess I'll hop in first. And the first thing I'll mention, I was just talking about personalization. I think that this is a very individual and personal decision, and that there's a lot of inputs and constraints that are unique. I think there's a lot of people that want to continue for a graduate degree, and it's just out of their reach in terms of affordability at the moment, and so they go into industry. I think the tech industry is among the most likely to subsidize or completely fund advanced degrees. And I know a lot of people, myself included, who their companies sponsor them to go and get a master's degree while they were working, and then continuing on to a PhD is more rare, but I've seen that too. When it comes to data science and other sort of more scientific and sort of like really deep engineering disciplines, a PhD doesn't just give you really sort of deep knowledge within a particular domain in an area of specialty. It hammers home over years the fundamental criticality of having, just believing heart and mind in the scientific method and of a rigorous and mature approach to analyzing a problem, collecting data, convincing yourself of the problem that you're actually solving, and then having your results be able to prove a skeptical audience. And so that's separate from whatever domain you study, going through a rigorous approach where you have to sort of like, discover new knowledge and convince other people of the truth of your discovery is really valuable in terms of data science. And what you find often is you might run into people who are sort of titans of industry and running a business area or running a company, and these people are already convinced in the brilliance of their gut feel. And so if you're a data scientist and you try to convince somebody who's phenomenally successful because of their track record of success without the benefit of data science, and you have some analytic product that recommends a course of action that differs from their preconceived notion, it's really, really hard to convince that person that data science is worth investing in. And I think that what you learn about how to convince people of new knowledge through the course of doing a topic-centric master's and thesis or going to the full PhD gives you a set of skills and experiences that you wouldn't get otherwise.
Agreed. Other thoughts?
I was frantically Googling everybody on my team to figure out what degrees they had. And so now that I've kind of come up with that, right, we have a PhD, 2 masters, and 3 bachelors out of the kind of 5 core data science team members, right? And so I think that, from a personal perspective, if I'm evaluating a candidate, I have a PhD as well, so I'm not included in that total. And the other PhD was also neuroscience. So it seems like that's a good background there, right, to kind of come in. But I guess if I'm evaluating a candidate, a PhD tells me something about that candidate. If you don't have a PhD, there needs to be other ways to demonstrate exactly what Nik's talking about, right? So the mechanical engineer, I have a bachelor's in mechanical engineering on our team, right? And he basically came and then he worked at a local other biotech for a while as like a process development engineer, got into data analytics, really learned a lot there, but also just understands a lot of the fundamentals, again, getting back to subject matter expertise, right, of what's going on and what we need, right? And a lot of that was stuff that he developed on his own, again, displaying the same qualities that Nik's talking about, right? So the PhD gives you room and space to go develop that, and also shows that you have had to succeed and do that on your own, which is possible to do out of a bachelor's. However, you also run the risk of getting very constrained coming out of the bachelor's, right? If you end up as a process engineer, right, he's fortunate that he was in a group that, furthered his career and helped him learn all these new things. That doesn't always happen, right? Whereas a PhD does give you that room to explore, right? So, and again, getting back to your funding, right, it's you can get funded and paid to go do a PhD if you're on the technical side. And so I think there's a lot of value there. So, talking to someone, talk to my kid or something, I think it's a good idea, right? That doesn't mean that you can't come straight out of a bachelor's if you find the right opportunity.
Yeah. If you inherently already have developed those skills or been fortunate enough, right? Yeah, to demonstrate a lot of those same sort of capabilities. Joost, anything else to add?
I agree with what was said, and I think to Nik's point, it's a personal decision, it's a financial decision sometimes, unfortunately. And I will add that I think data science is a very democratic field in that there is so much available online to learn. So if you make that personal decision to forego a graduate degree, there certainly is an opportunity to look up techniques and methods and applications and learn about them in online courses, use data that's available online, and develop your skills that way. I'm really open to either journey, whatever works best for you, as long as you sort of develop those skills that we talked about at the start.
Great. Okay, good. So I have another question that came in, and it's a really important one. I'm glad it came in. So, and it's around data science organization within your firms, right? And I'll just give a little context, right? I spent a lot of time writing about the importance of structure of analytics teams, and like a company like Fico has about 400 data scientists, different functions, right? There's a lot of coordination and structure, right? Because you can't have 15 different religions in terms of how you're going to build models or govern models or show that they're ethical or biased, right? You kind of need to have a standard. And more so, right, if you have that standard to govern how models are built, right, you can enforce it, you can improve it, right, and you can demonstrate that to your board so that the CRO of your company can look and make sure that they're not taking a huge risk with, each data scientist or each data science team having, their own sort of methodologies and religions around how to build and test and govern these models. So I have a particular vantage point. My vantage point is that I'm big on centralization and around standards of governance, and that's probably influenced by the fact that the majority of models that I build and my team builds, right, and Fico builds are for external customers, right? So governance around this, because they're out of our touch, they're in our customers' hands, is really important, and there's a size and a scope. But there's lots of competing factors, right? So, for example, I moonlighted at Amazon, and when I was at Amazon, it was very much a software company where data science was a nice to have, but it wasn't the primary sort of driver, right? And so I was just curious if each of you can talk a little bit about your firms and how data science is organized, right? Who do you report up through? How do you work with the different teams, right? How does the decision making work? Back to a lot of the great conversation topics that Chris and Joost are bringing up about communication, right? And how we influencing decisions within the firm. So could you each comment on that? How you organize, and what works maybe, and maybe what can be improved if you have vantage points on that in terms of the data science organizations and how they operate in your firms. Joost, do you want to start us off?
Yeah, sure. So I think this is sort of part of the natural analytical maturity process of any organization, is figuring out what works best for them in terms of centralized or decentralized data science. I've seen it in done in different ways. For us, we have a central data science team that sort of works across different stakeholders, across different departments, answers different questions from different groups. And then you also have more embedded roles of analytics specialists and data scientists who are really focused on a specific business area. I mentioned algorithm engineering as a good example. We're really focused on glucose prediction, signal processing, things like that. And I think that's really valuable because some areas are so specialized that you really need people who know everything about that. And then I think where that goes for Dexcom in the future, centralized, decentralized, I don't know, and I think we'll just continue to evolve as an organization and see what works best for us.
Got it. Nick?
Yeah, I think it's kind of interesting because I feel like I'm lucky enough. I think I'm lucky enough, as many of you are, to work at a company that has experienced sustained growth, and so we're always complaining about the growing pains, which is a good problem to have. And we started off with a fairly centralized analytics organization because we were already had decades of experience building product, and then moving into the service industry, and then understanding that you can't really operate and continually improve your current service or better inform what your future services will be without data. We started with a central data organization with a large number of software engineers building our infrastructure, our data infrastructure, data storage, authentication, data catalogs, all these things, and with a layer of data science serving the organization. And then as Viasat has grown, we've always run into friction and sort of waffled between how much is centralized and how much is sort of like how much of our analytics function is moved directly within the business areas. Because of that, what Joost was just saying about areas requiring specialty. So understanding in-flight connectivity markets is different than understanding rural villages and site selection for the developing world or developing economies globally is different than US residential or European residential. And within Europe, you can't just sort of paint a broad brush and say that the entire continent is the same. And so to me personally, it feels a little bit like this thrashing between centralization and decentralization is almost like a person trying to figure out their diet and waffling between being vegan and being on the Atkins diet, for those of us who remember just eating meat for every meal. And I think at some point we're gonna come to some kind of equilibrium. But the equilibrium point is always changing as the company grows and flexes. Different parts of the business get emphasized. So I think for us, the key differentiator as part of our corporate culture is just trust that people are making decisions with the best of intentions, and that we have integrity, and that we're always willing to learn, and we're always willing to experiment, and that we hold ourselves. I really like what you said, Scott, about sort of governance, and you can't have 15 different religions and all that stuff. Where we're trying to make sure that we maintain centralization is in what are our expectations for how our data scientists do work? What is our expectations in terms of the tooling and the platform and the infrastructure, so that if you're a data scientist over here and then you move over there, you're only having to learn a new business. You don't have to learn an entirely new tech stack in order to do the same job you've been doing for years for another part of the same company.
Yep, that makes sense. Chris, thoughts about how you're organized?
Yeah, I would say that organized is probably a strong word for us at the moment. I would say that, you know, for us, we're a startup, right? And so when I joined in 2017, there were 6 of us, and not 6 data scientists. There were 6 people total at the company, right? And so in that case, right, your data science was me turning over to the one software guy, and then deciding what would be a good idea, and then turning to the CEO and telling him what we were going to do, or something like that, right? And so kind of we've evolved from there. Mostly in the last year, we grew in the last year from about 30 to 120 people based on the, you know, pandemic response, developing COVID tests and things like that. And so now we're at the point where we have to decide how we want to govern data science, right? We're centralized because there's 6 of us, right? You know, on the team right now, but then how do we develop a structure, right, that will scale with our organization over the next 5 years, you know, 10 years as we grow and become more mature? How do we deploy data science out throughout the organization? You know, what is that method of governance that allows us to still be flexible? Because we don't want to use the same governance policies you have, Scott, right, at a 400 data scientist organization, when they also still are only a couple of us that talk to each other all day long, right? And so kind of we're at this interesting point now where how we, you know, thinking about how are we informed of, you know, what everyone's doing now that we're a little bit more separate and we have more projects running at the same time, but also really ensure that everybody's empowered to be able to make impacts on the different areas that they're deployed in. So, you know, we're right in the thick of that discussion, which I think is really exciting, you know, to be able to form an organization really from scratch and decide how it's going to be, and hopefully have this lasting long-term structure that, you know, someone like Nik and, you know, down the road will be like, I'm really happy that we have this structure, or something like that, right? So we're very early on, which is a really kind of exciting and interesting time.
Great, yeah, and that's great that we have that perspective too. And I think, you know, we're nearing the end of our time here, and I think I could go on for 3 days with you gentlemen if you had the patience for me. But I think, you know, we raised a lot of different topics, right? We talked about that in San Diego. We're solving really important problems, right? And these are companies that are really making a difference. And, you know, at the same time, right, we understand that some of our companies are a little bit smaller, some of ours are a little bit larger, but we have the regulation that's coming down in terms of how we're going to operate. We have threats, right, or opportunities. Things like open source and AutoML could be both a threat or an opportunity, right, depending on one's vantage points. And I think what's really important, right, is things like what we're doing today. The fact that we can listen to one another, share perspectives, and make connections, right? So I really appreciate, you know, Chris, Joost, and Nik, you know, making the connections and spending time with me, so I can learn from each of you. I hope those that are listening are similarly, you know, learning and making those connections. For me, San Diego is one of these places that I'm super proud of being part of, right? It's a great honor to be in a place where I think I have some of the best machine learning and data science colleagues across all of our different firms. And so I'm really excited about this mission. I'm pleased that Kevin asked me to chair this panel. And I'm excited to see how we all collaborate together, right, to make sure that we are continuing to drive San Diego as the continued premier data science hub, that we drive truly unique and innovative sort of solutions that change the world, but we also show a level of maturity and self-inspection with respect to what we're doing from a machine learning perspective, a data science perspective, that we allow ourselves to kind of continue to mature and grow as an industry. And that's a big part of what, obviously this series is about, but also the organization Tech San Diego and what I have a pleasure of being part of. So with that, I'd like to thank you all. It's been super interesting, and thank you for what you've done for data science within San Diego. And then I'll turn it over to Kevin.
So first of all, a virtual clap for everyone. What a great presentation, and thank you, Scott, for moderating that. We have a number of questions that were around, undergraduates finding positions, right? And this is a major effort for Tech San Diego. In fact, through our Jacobs Talent Initiative, we have a person who sits on campus, used to sit on campus, now of course is doing it virtually, to encourage students to select the region as their career destination. But one of the challenges is, and we saw several questions that aligned to it, was getting that first job, right? And one of the things, I'd like to say a couple things on that. One of the things is, and Eric Mion at HDSI and I have talked about this, these are pretty sophisticated companies, Viasat and Chromacode and Dexcom, but some of them will put out job descriptions for entry-level data scientists that read like they should be a PhD. So if you're looking at some of these jobs, job descriptions, don't always be scared of applying for ones, even though they may look more complex than they are. The second thing, and now is not a good time for it, but when internships start ramping up, you really got to look at internships. I mean, Viasat is probably one of the best in the country at running just a premier internship program, but all these companies, when they're in the office, have internships, and you really need to understand, who are the big data science employers. And by the way, it's not always tech. Petco has a whole bunch of data scientists, right? So it's not just technology companies, but start building your list for companies that that are hiring data scientists. I don't know if you guys want to add to that, but I just, there is this gap between, good, I have my bachelor's degree, where are my job offers? I don't know if you guys want to address that real quick.
Yeah, I'll hop in real quick and just say something about this idea that entry-level recs are reading like somebody has a PhD plus years of experience. I think that companies, especially data-driven companies, need to understand the effects of writing a rec that's unrealistic. And the reality is that we're going to filter out a bunch of otherwise really phenomenal candidates if people coming in feel unqualified. And it also damages our own credibility if we say this is what we expect an entry-level person to do. That doesn't help build your reputation for really understanding what's going on and what the student experience is. And so hopefully we're not doing that. And if we are, we quickly detect and learn from that and correct it. The other thing is, I just wanted to say 1000% agree with you that San Diego, like all of us sort of working together to elevate San Diego, is phenomenal because it gives us the opportunity to, it gives us the privilege of competing with each other. Our data scientists are only going to stay if we're the best option locally, but people aren't going to want to come to San Diego if there's not a diversity of options. Because one of the things that other metro areas have is the perception that, well, if the job I'm accepting doesn't work out, I know that there's going to be plenty of other fallback options. And that creates sort of an emotional safety net for making a pretty big career decision, especially if it involves, picking up and moving to a new city. And what I love about this community that we're building is I want my data scientists who are interested in exploring other options to explore them with you. And if they're even more successful with you, great, because all of us benefit from the ways that all of the rest of the companies in San Diego are affecting our lives and our future. And if it doesn't work out, great, come back. We would love to have you back. And I think that that's kind of the ecosystem. I want the tech industry to sort of be internally competitive and collaborative, the way that our microbrewing industry is, right? Like that's what I would love to see among sort of software and data science in San Diego.
Well, I think we could all drink to that.
Yeah.
Not yet, though.
I think
all
exploring the microbrewing industry in more detail as a model would be a great idea.
Next event. Yep.
We do have tech mixers and we do go to microbreweries. So keep your eye on your inbox and we'll make sure you get that invitation. Okay, here's what we're gonna do. We've been on since 8 o'clock this morning. We are gonna take, and we are gonna be really sharp on this. We are gonna take a 10-minute bio break. Make a phone call, do what you need to do. A lot of us are gonna stay on the line here, but go ahead and take a 10-minute break. We're gonna come back at 10:08. We're gonna come back and we're gonna start our lightning talks, which there are some incredible topics on that. Really looking forward to it. Let's take a quick break and we will come back. Once again, thank you, Scott. Thank you, Nick. Thank you, Chris. Thank you, Joost, and thank you, Teradata, for sponsoring this panel. Thank you very much, and we'll see you at 10:08.
Thanks, everybody.
All right, thanks.
Thanks.
Sarah, and am I missing anything?
Nope, you're all good.
Do I need to be the only one on camera, or can I go off camera?
You can go off camera.
I am going to go on mute, and I will be back myself in 5 minutes.
Sounds good.
10:06. I'm 2 minutes early. Which is always a good sign.
By the way, Calvin,
Yes, sir.
can you hear me? Can you see me? Jeffrey.
I can. Kyle, how are you?
No, this is Jeffrey.
Oh, Jeffrey, how are you?
I just want to let you know that I have already logged on and I'll come back in on at 11.
All right. Yeah, come in a couple minutes early, just in case, but looking forward to your keynote.
Sorry, not
Jeffrey.
11, 12. Yeah, I mean 11:45, 11:50. But
Yeah.
I'll be here. I actually have been logging on since 8 o'clock this morning.
Yeah, good. Looking forward to it. Are you enjoying the content so far?
Very much, very much. Amazing panel.
All right, thanks.
All right, okay.
Okay. Kyle, can you come on with me for a second?
Sure. Can you see me there and hear me?
Yeah, I can. Jeffrey, you can go ahead and mute yourself so we don't have a box there for you. Okay. And then we have Mr. Sanders, who I take it is going to be one of the Lightning Talk guests. Okay, so let's wait one more minute to get people on, and then we'll get started.
Can I put a like a Rady background? Like, is there a way to do that?
Control all no, Robert, there is not.
This is we use
GoToMeeting,
yeah.
which in the beginning was a much more secure platform. I know a lot of the other platforms are now just but we stay to the same platform, and the webinar platform for GoToWebinar seems to work a little better. So unfortunately, we don't have the fake backgrounds. In fact, if you notice, my background is just it's fake, but it's real fake.
So I have to go to Rady and then get in front of it and set up shop there to get that nice building.
Just where you are is fine.
Okay, I'm just kidding. Yeah. All right. So I'll be. I'm at like I think 10:45, so I'll just be around.
Okay. So why don't you go off screen, and then Kyle will be the one that introduces you. He'll bring you on. Okay.
Okay. Great. Thanks.
So welcome back. I hope everyone had a very quick break. We are going to now move into our lightning talks, and to help us moderate that section is Kyle. Kyle, how do you? I'm going to say Kyle Hofer-Mora. Would that be correct?
Sure, that works. Yeah, Kyle Hofer or Kyle Hofer-Mora. Either way is fine. I actually.
Kyle serves as Assistant Director for External Relations and Strategic Initiatives at HDSI. In this capacity, Kyle works with a talented team focused on industry partnerships, as well as faculty members to strategically grow new graduate and professional programs. He is responsible for the development and implementation of strategies to promote and expand HDSI's program offerings and overall reach. So Kyle, I am going to go off screen. I'm going to turn it over to you to moderate all of the lightning talks, and I'm going to assume that people can continue to use the question box, and you'll be monitoring those, and you'll catch those at the end. Would that be correct?
That is correct.
Okay, I'm going to go off screen. It is all yours.
All right. Thank you, Kevin. I'm actually just looking to make sure that we have our first faculty lightning talk, our faculty member present. I'm not sure if she is having some technical difficulties, so just give me a moment here to make sure that Sally is able to connect. So bear with me just a moment.
For those of you come back from the break, we're just making sure all of our logistics are set up and getting our lightning talk speakers all in line.
Yeah, we're actually going to switch the order out just to make sure that Sally can join us and present. But while we get Robert set up, as Kevin mentioned, I'm the Assistant Director of External Relations and Strategic Initiatives at HDSI. I joined this past summer in a newly created role and overseeing our industry relations team. So you heard from our industry partners, Dexcom and Viasat, earlier in the panel discussion. And so if anyone is interested in seeing ways in which they can get involved with our students, feel free to reach out, and our industry relations manager, Eric Nyon, would be happy to discuss, different ways to get involved. So I'll be moderating our faculty lightning talks, of which there are 5, and we will have some Q&A time, but this will be at the conclusion of all 5 talks, not after each individual speaker. So if you could use the question box there to submit your questions, I will moderate those. And because we have 5 faculty members who are, coming from different backgrounds, both in the business school and in the Data Science Institute, and all 5 are talking about slightly different topics. If you do have a specific question, if you could note in the question which faculty member that is directed to, that would make my life a lot easier for responding to those later on. So I think we are going to start with Dr. Robert Sanders, who's an assistant professor of marketing at the Rady School of Management, who will be speaking about customer inattention to expiration dates. Robert's research interests include pricing experiments, dynamic decision-making, sustainability, and the intersection of business economics and public policy. His current research involves studying both the causes and solutions to the problem of retail food waste. This interdisciplinary stream of work combines marketing, operations research, and economics, and enables businesses to price their perishable products more intelligently. He also has research exploring the role of consumer information in the price premium that branded goods command over their private label competitors. Sanders was named a Clayton Dissertation Proposal Competition winner in 2017. He was also awarded the Industrial Organization Research Grant from the Becker-Friedman Institute at the University of Chicago in that same year. Robert earned his PhD from the University of Chicago's Booth School of Business in 2018 and his bachelor's in economics from Wharton School of Business in 2012. So with that, I will turn it over to Robert to begin his presentation.
All right, thank you. Excellent. You guys can hear me, right? Cool. Okay, so yeah, I'm excited to talk about this work today. This is joint with Carson Hansen and Kanishka Misra. It's called Consumer Inattention to Expiration Dates, a field study. So as the title alludes to, this is a paper about consumer choice over expiration dates. When you walk into the grocery store, you're often going to see a bunch of products, but even within a product, you're going to see multiple expiration dates for sale, often at the same price. And so some of you might be the kind of people who, you walk in, you grab the first milk you see off the shelf and you bolt, get out of there. Others might spend a little bit more time, look through the shelf, maybe reach towards the back, see if you can find a later expiration date. So it turns out that what consumers do here in aggregate actually has pretty big implications for retailers and society alike. So what are those? So first of all, when consumers spend a little bit of time and sift through the inventory, they potentially leave some of the older items on the shelf to spoil. And as you know, once an item hits its expiration date, the retailer's going to take it off. They're not going to sell old items if they know they're there. And perishables, they're, to give you some perspective, they're over 50% of grocery store revenues at this point. So this is $268 billion. There was $57 billion in retail prices wasted in 2016. So managers look at this category, look at these categories, and they see an opportunity. Any chance to reduce the amount of waste here, you're going to be able to potentially increase profits. So that's from the retailer side. On the other hand, as I mentioned, this is a problem to society, particularly because when organic waste gets sent to the landfill after it expires on the shelf, it carries with it this externality in the form of greenhouse gases, particularly methane. So this is a really potent greenhouse gas, which surprisingly, I don't know if this is news to you guys, but for me, this was pretty striking that 8 to 10% of all greenhouse gases emitted by mankind or humans is from food waste, not upstream, just the food waste alone. And so to give you some more perspective on this, there's an organization called Project Drawdown that lists the top 100 ways we as a species can mitigate climate change. Food waste has ranked third, no matter really how you slice it. They do it a few ways, and food waste is consistently up there. One of the largest offenders, according to the USDA, in terms of its footprint, is going to be meat, and so that's what I'll focus on today. Okay, so what do we currently know about how consumers make decisions over expiration dates in the store? You can see clear there's the link here between their behavior and the waste, but what do we know? So as I mentioned, we've got anecdotes. We've got the kind of person who sifts, and we've got the kind of person who just takes the first item. That's not as systematic as we'd like to be. So then we can look at the survey literature. This is where consumers self-report. If you just ask them, what do you do when you go to the grocery store? Do you pay attention to the expiration dates? Here we find about 80% of consumers will claim full information. They'll say, yeah, I look at the expiration. I try to buy the freshest thing on the shelf. Okay, but nothing as far as the way we have in terms of behavior in the field, right? So if we would want to look at the data and see what are consumers actually doing, this is something that there are no papers on. There's no studies on this. And I'll talk about why that is in a moment. But what that means at this point is that our current knowledge really about consumer preferences and behavior with respect to these expiration dates is really based on either our priors and our anecdotes or on the stated behavior of what they say they do. So what we're going to try to do today, and I'm going to preview this for you guys, is show you in the data how consumers actually behave with respect to expiration dates. I'm going to show you evidence, to what extent they pay attention to these, and then I'll also say a little bit about why they either do or don't pay attention. So specifically, for example, if we observe people not paying attention to expiration dates, this could be because of one of two reasons. It could be the case that people just don't care about expiration dates in the sense that, look, I'm going to eat it tonight. I don't really care. All the stuff on the shelf is more or less good for me. So I don't bother sifting. Or it could be the case that I actually do care, but it's even worse to look through the shelf and inspect each individual item. So forget that, right? The reason this matters is actually this has different implications for what the retailer management strategies might be to manage their perishables, right? We'll talk about that towards the end. All right, so this being a data science talk, let me talk about the data. So traditional scanner data, you're going to observe items at the SKU level. That's not quite enough to do what we want to do. So we had to get a data set that observed items at the physical item level with expiration dates. We also needed to observe items on the shelf. Basically, we need to know what consumers were choosing between. So this is really hard data to come by in the grocery retail industry. Inventory data are typically not reliable. Here we're going to know at all points in time what's on the shelf, exactly how long it has to expiration. Furthermore, we're going to have a proxy for item location. So why is it that the newest milk is towards the back of the shelf and the oldest stuff is up front? That's because retailers engage in this practice called stock rotation, where they put these oldest vintages or oldest expiration dates towards the front of the shelf in the hope that it nudges consumers to choose them. We're going to be able to observe that in the data. To get all this data was a pretty big undertaking. It involved cooperating multiple firms. There's more about that in the paper. I don't have time to get into it here, but there was a retailer, a wholesaler, and a pricing solutions company called Wasteless. At the end, we ended up with about 26 SKUs, 5 subcategories, fresh raw chicken, meatballs, meatloaf, things like that. They're listed here. The maximum shelf life ranged from about 8 to 11 days. The data lasted about a year and came in a few pieces. So we have about 20,000 choices that consumers are making throughout this year that contain at least more than one vintage on the shelf, right? So there's sometimes you go to the shelf, there's only one expiration date. Those aren't interesting. When there's multiple expiration dates, that's the choice sets we're interested in. Inventory is about 50,000 units that come through the shelf at this point in time, and then over this duration, and then we're also going to introduce a little bit of a price experiment at the end that's going to allow us to quantify exactly how much consumers are willing to pay for an extra day and how much of a pain it is for them to search through the shelf. We want to put those in dollar terms, so I'll wrap up with that at the end if we have time. Okay, so let me just give you some nomenclature. We've got this is what the choice sets look like. You've got the digital shelf labels above. You've got the, each of these is a separate SKU, and then you've got different vintages within this, right? So this one might be older than this one, and the consumer can take it. This is the top, so the retailer puts the oldest stuff up top, and then the newest stuff towards the bottom. So you'd really have to dig through the shelf to get those newer items, which is a particular hassle here, you can see. When I say vintage, by the way, I mean relative expiration date, so oldest versus newest versus intermediate. All right, so let's summarize the data really quickly. So what does the average shelf look like for these consumers? About 20 units are on the shelf at any point in time, although this varies considerably. This is the distribution here. You've got about 2.5 vintages on the shelf, although this ranges from 2 to 6. So you can have 6 unique dates on the shelf at any point in time. Typically 2.5, 2 to 3 is sort of the modal number. Days until expiration, you've got about, the mode is 6, although this varies considerably as well, particularly when you start to get into 0, 1, or 2 days, you'd think consumers would care. And that's good variation. We want to have that to pick up, see if consumer behavior changes at these points. And then lastly, this is the distribution of the percentage of the share of shelf that is the oldest vintage. Right, so the average here is going to be about 25. So of this average shelf, expect maybe 3 or 4 of these units to be the oldest vintage. The rest are going to be newer. All right, so we're going to be interested in seeing, when do consumers choose this oldest item on the shelf, particularly when it's priced the same, because this is strictly dominated at this point, right? So if consumers were perfectly paying attention and preferred later expiration dates, we would expect this number to be a complete 0, right? They would never choose this item. Of course, that's not what we find. Consumers do have search costs or hassle costs, and they, to whatever extent, maybe they care about it. We don't know. But at this point, we can say 35% of them are choosing the very oldest item on the shelf. So this is in excess of 0. It's even in excess of what the survey literature found, which we would expect at most 20, those people who say, yeah, I don't pay attention to the expiration dates. And then if those were, if they were all choosing old, we'd get 20. If they were randomly choosing, maybe we'd get about 5, right? But we're getting 35. So more evidence of intention here is this graph. So take a look, the x-axis is the share of the oldest vintage that's on the shelf, basically on the supply side. The y-axis is the demand side, is the choice share of the oldest vintage. So merely increasing the share of shelf, just putting more of this old stuff on the shelf, increases the percentage of consumer choices that choose the oldest item on the shelf. But maybe this is confounded, right? Maybe there's something about, when there's a lot of old stuff on the shelf looks different, or it's newer. But lo and behold, you can control for the age. Here's a specification curve I want to show you really quickly. This is like a table, a regression table, but instead of showing you 5 or 6 specifications, I'm going to show you over 1,000. Okay, so if you now control for a variety of things like item location, item age, fixed effects, this is going to show you the marginal effect. If you increase the share of shelf by 1 percentage point, how much does the choice share of the oldest item increase? It's about 1%. It's about completely commensurate, right? No matter what you control for. So this is what we can take from this. I'll show you another one of these in a moment. Okay, take a pause here. So having established, right, that there's some inattention, more than we might expect, let's see if we can parse out why, right? Is it this they don't care story, or is it that they do care, but it's really costly? So first, let's see, do they care? So let's look at the x-axis here. This is variation in the days left until expiration. I said we were going to use that. The y-axis is the choice share of the oldest. The dark blue is the choice share. The light blue, don't worry about it for the purposes of this talk. What I want you to take away from this is that the dark blue line, the bars are increasing pretty considerably as you go from left to right. Okay, and this suggests that, hey, maybe consumers actually, they're more likely to buy the oldest item when it's got a long time left. They look at it and they say, fine, maybe it's the oldest item, but it's 10 days left, it's fine. If it's got 3 days left, they're going to keep looking. Is this robust? Well, yes. So if you control for all the other things that you might be worried about, as long as you control for location, right, you're going to get a statistically significant and economically meaningful effect here. So one percentage, so 1 extra day increases to about 1.5 to 2 percentage points choice share of the oldest item if you've got an extra day on that item. All right, so let me kind of wrap up here. I got like 2 more things to show you. So, okay, so that convinced you potentially of the preference. What about the hassle cost? All right, so take a look at this graph. The left axis, so it's the x-axis again is days until expiration. The y-axis is choice share. Okay, left side is organized, right side is disorganized. Organized means, again, the oldest stuff is on top. So merely moving the oldest stuff on top increases the choice share considerably, huge, right? This is 12 to 20, over 20 percentage points. It's like a doubling, right? Or even more so in certain cases of people choosing the oldest stuff just simply by it being up front. They really don't like looking through the shelf. They really don't like reaching down, given the choice architecture. That's not surprising. But the other thing to note is that look at the slopes here, right? Here the slope is basically non-existent. Here you get an even steeper slope than the previous graph showed. If you were to scale it, you would see that. But the reason is because now these items are up front, so consumers respond to the variation in expiration dates. but they're not here. They don't when the items are merely kind of strewn about the shelf, right? They're not systematically up there for them to see. And so this is consistent, right, with them having this really large preference, but also a really large hassle cost. And if we want to quantify this, this will be the last point I want to make. We would need some kind of variation in the prices of these vintages, which is pretty hard to get. Sometimes retailers, particularly in other countries, will do dynamic discounts, right? On the oldest items, you get discount, but not often in America. Maybe you'll see it once in a while on meat. Here we got them to introduce exogenous discounts on all of these products at certain points in time. And we're going to use that plus a choice model, right? Where we model consumer vintage choice to back out, what the preference is and what the hassle cost of looking through the shelf is. So let me skip that and just get to the result. What we find is that consumer preferences for an additional day are pretty large, right? So people would pay 21 to 27 cents more if the product had an extra day. Think about the range of dates. We had 0 to 10 or so. That's about $2, right? Something that's going to expire the same day. So those imply, pretty large valuations. Then the hassle cost is also pretty large. So it takes $1.14 in disutility in dollar terms off of the consumer's, well-being, basically their surplus, when they have to look through the back of the shelf. So lastly, this research, we think is really interesting. It has implications for what retailers do as far as stock rotation, dynamic discounts. What does the dynamic discount policy look like? How does that interact potentially with something like stock rotation that has this really large marginal cost of conducting, but is really effective? And we want to then tie these outcomes to ultimately to waste and profits. We think the retailers would be most interested in those. So let me wrap up with that, and yeah, we'll turn it over to the next panelist. Thanks.
Thanks so much, Robert. That was a really great talk, and I'm gonna probably have a different experience at the grocery store after this. So thank you so much for that. And we will have Q&A at the end of all 5 talks. So stick around for that, but thank you. All right, next we will have Dr. Sally Sadoff joining us. She is an associate professor of economics and strategic management at Rady. And her research focuses on applications of behavioral economics in field settings. Her work tests behavioral economic models in the field, incorporates insights from behavioral economics into the design of policy relevant interventions, and advances methods and applications of experimentation in economics. Prior to coming to the Rady School of Management, Sadoff was a postdoctoral scholar at the University of Chicago. She earned her PhD and MA in economics from the University of Chicago, and her BA in economics is from Harvard University. She will be speaking to us today about lifestyle and mental health disruptions during COVID. And welcome, Sally.
Hi, thanks for having me. Really nice to have this opportunity to talk about how we're using data science to better understand lifestyle and mental health disruptions during COVID-19. So, oh, excuse me. Whoops. Sorry, let me just get my tech here. Is this working still?
I can see you, but your slides went away.
Yeah. Nope. Let me try again. Not sure what happened to them. How about now?
No, we just see your camera.
Sorry about that. Let me try again.
Sarah, are you online to help out? There you go.
Is it showing now?
Yes.
Yep, you're visible.
Right, you're seeing the slides?
Yep, we can see your screen.
Okay, great. So as many of you may know, a mental health crisis has emerged during the COVID-19 pandemic, particularly for adolescents and young adults. A CDC study of US mental health in June 2020 estimated that about a half of 18 to 24-year-olds were suffering from anxiety or depressive disorder, and a quarter reported considering suicide in the prior month. What we are doing here in our study is taking advantage of an ongoing wellness study at the University of Pittsburgh that we started conducting prior to the pandemic, and to better understand how the pandemic has affected both lifestyle behaviors and hopefully to help us inform this mental health crisis that we're seeing. Participants receive wearable devices, Fitbits, for a semester, which measure their physical activity and sleep based on heart rate and movement. They also answer repeated surveys about time use and well-being. And because we started the study prior to the pandemic, we're able to compare participants who were in the study in 2019, before the pandemic occurred, to a cohort of students that participated in the spring of 2020. They enrolled in the study prior to the pandemic and then continued their participation through the pandemic. And we're going to be comparing these cohorts to try to understand the effect of the pandemic on lifestyle and mental health. Here I'm showing you average steps per day and average activity. Yes?
Sorry to interrupt. Your slides are not advancing for some reason on our view, and I just, since you're going over a figure, I wanted to make sure we check.
Let's see.
Yes, that's better, or at least it seems.
Now, are you seeing it?
Yeah, physical activity spring 2019 versus spring 2020. Is that what we're supposed to be? Yep.
Yes. I'll try to keep, maybe if I keep them like this, you'll be able to see them better. So this plots average daily steps over the course of the semester from February to April in 2019 in blue compared to 2020 in red. And if you first look at the blue line, you see that average steps per day were pretty flat over the semester, averaging about 10,000 steps per day. If you look at the beginning of the semester, the spring 2020 cohort looks very similar to the spring 2019 cohort, also walking 10,000 steps per day. But when March hits with the pandemic, we see this really steep decline in steps per day. Steps decline by about 5,400 steps per day to 4,600 steps on average, and over 50% decrease. We see similar declines in active hours per day. This is activity that lasts at least 10 minutes and raises heart rate. Active hours decline by an hour and a half, from 4.4 to 2.9 hours per day, which is a 34% decrease. Sleep, the pictures aren't quite as clean, but you see, again, this pattern where there's this steep change for the spring 2020 cohort in March. So they're sleeping about 25 to 30 minutes more per day starting in March and going through April. And this is driven by later wake up times. They're waking up about 30 to 40 minutes later. Bedtime also increases, but not as much. This figure is showing self-reported screen time and social interaction. Screen time includes time spent playing games, watching television, or surfing the internet, and does not include time spent working or studying on a device. If you look in spring 2019, you compare February, the start of the semester, to April, the end of the semester, we see slight increases between February and April in 2019. By contrast, you see this really large jump in 2020 with screen time more than doubling to over 5 hours a day. Turning to social interactions, which is time spent with friends, again, we see slight increases in 2019 between February and April. In 2020, we see this really sharp decline, which social time drops by over half to less than 30 minutes a day. And then sort of coming to mental health now, we measure mental health using the CESD, the Center for Epidemiologic Studies Depression Scale. A CESD score above 15 is considered at risk of depression, and I will be talking a lot about that, sort of predicting who's at risk of depression. By that I mean someone with a CESD score above 15. In 2019, average CESD scores increased slightly over the semester from about 12 to about 14. In 2020, again, we see these large jumps. So in February, students are reporting very similar levels of depression as in the start of the semester in 2019. So again, starting around baseline levels of 12. But by March, which is our midline 2020 survey, these scores have jumped to 18 and they jumped to almost 20 by the end of the semester in April 2020. As a result, we estimate that at baseline, about 32% of our sample is at risk of depression. By the end of the semester, this almost doubles to 61% of our sample. And I should say that we're continuing to track students, and depression rates have gone down, but certainly not to baseline. We estimate that about 50% of students are still at risk of depression. So what we do is try to bring together all these different measures, the biometric measures, the time survey measures, and use them to see if we can better understand who is at risk of depression, particularly during the pandemic, where we see these really dramatic increases in levels of depression. So we combine our rich data to identify risk factors for end-line depression, meaning whether someone has a CESD score above 15. To do this, we use our baseline measures of mental health, demographics, and then differences between end-line and baseline measures of physical activity, sleep, and time use. So those changes that I just showed you in those figures. We use an XGBoost decision tree-based algorithm, which, similar to random forest, selects splits of features to maximize predictive accuracy. And the features are those, the baseline measures of mental health and these changes in lifestyle behaviors. We pool the spring and fall 2019 cohorts, those that participated prior to the pandemic, and we achieve 89% predictive accuracy, again, predicting whether someone is above or below this threshold of 15 at the end of the semester. In spring 2020, we achieved 91% predictive accuracy. This figure shows the cumulative feature importance of baseline mental health measures, time use, physical activity, sleep, and demographics. And if you look on the left-hand side, you see that in 2019, over 50% of end-line depression can be explained by baseline measures of mental health. That's this dark purple bar. And all the top 3 features in terms of importance are all baseline measures of mental health. In particular, baseline CESD is by far the leading factor explaining end-line mental health. So if you're depressed in February, you're likely to be depressed in April. The other measures are the GAD-7, which is a baseline measure of anxiety, and life satisfaction. What we see in spring 2020 during the pandemic is this really large shift in what are the risk factors for depression. We see a decrease in the importance of mental health and an increase in the importance of these changes in lifestyle behaviors. In particular, we see that physical activity differences emerge as the second most important feature for predicting end-line depression, even more important than your baseline measure of mental health. So zooming in on physical activity differences, this figure shows the SHAP values for predicting end-line mental health, but by the change in daily active hours over the semester. So a SHAP value can be thought of as the marginal contribution of a given value to the probability of having a CESD score above 15. A positive SHAP value indicates increased risk of depression. A negative SHAP value indicates decreased risk of depression. If we look at the blue line, which is the 2019 SHAP values, you see that they're close to 0 and the line is fairly flat, indicating there's not much of a relationship between changes in active hours and end-line depression in 2019. In 2020, we see this very strong relationship. So people who have reduced active hours between 1 and 2 hours, which is the average person during the pandemic decreases their active hours between 1 and 2 hours. Those people have increased risk of depression at the end of the semester. And I think what is striking to us is those people who are close to 0 in their change in active hours have greatly reduced risk of depression. So it suggests that those people who are able to maintain their physical activity habits were at much lower risk of depression during the pandemic. Based on this finding, In June 2020, we implemented a randomized experiment assigning our participants to a treatment or a control group. For 2 weeks, participants in the treatment group received $5 every day they walked at least 10,000 steps, and we compare this to the control group that received no incentives. This figure again is tracking daily average steps over the semester. So that first dip is what I already showed you, the steep decline in March. You see that after the semester ends in April, there is some recovery in steps, and hopefully you can see where our experiment took place in June, this big bump in the blue line. We increased steps, our incentives, the $5 a day incentives, increased steps by about 2,300 steps per day compared to the control group. After our intervention ended, steps quickly declined back to baseline. So we have this big impact, at least during the intervention period, on physical activity. But if we then take this to mental health, what we find is that we had no impact on CESD scores. So these columns show the control group in red, the treatment group in blue, their average CESD score just before the intervention, just after the intervention, and a month after the intervention. And you can see that over time, CESD scores are declining slightly. There's some improvement in mental health, but there's no difference between the red and blue bars, showing that while we did increase physical activity, it had no impact on our participants' mental health, at least as we measure it here. So, sort of summarizing our findings, we find that declines in physical activity are a leading risk factor for depression during the pandemic. Our intervention substantially increases physical activity, but it does not improve mental health, suggesting that that finding we found, this strong association between physical activity and mental health, might not necessarily be a causal one. At least it might not be in the direction that physical health is necessarily causing these depression scores. And so we need to better understand what is driving these linkages. In conclusion, we want to sort of advertise that applying data science to biometric data can help us better understand the linkages between physical and mental health. But we really want to highlight that something that our study shows, and we didn't set out to do this, but our study does highlight that data science alone does not identify causal relationships. These associations we found in the data did not bear out when we ran the randomized experiment. It could be that we need to run it longer, we need to run a different type of intervention, but the causal linkages are not necessarily clear and can't be fully understood just by using the observational data. And so if I leave you with one thing today, I really want to encourage you that you can learn more from your data if you combine data science with experimentation.
Great, thank you so much, Zoli. That's a interesting and very salient point to end on there. And I think all of us, having gone through this past year of COVID, can certainly relate to this experiment. So thank you for sharing that, and we will have a Q&A following all faculty member talks, so hope you can stick around for that. And before I bring up the next speaker, I did just want to reiterate that we do have Q&A after this session, and you can use the question box. So please feel free to submit your questions there, and if it's directed at a particular faculty member, if you could note that in your question, that would be great. All right, so give me a moment here to transition between speakers, and we will move forward. All right, let's see. Okay, so by the way, I don't know if I mentioned this. I mean, I know it was part of each of their bios, but the first two speakers were from the Rady School of Management, and our next speaker is from HDSI. Again, just overall with this event, the collaboration between Tech San Diego, Rady School of Management, and HDSI, I think is a great intersection between data science and the business community. So our third faculty lightning talk is going to be from Dr. Benjamin Smar, who's an assistant professor of bioengineering and a professor at HDSI. He is an NIH fellow as an NIH fellow at UC Berkeley. He developed techniques for extracting health and performance predictors from repeated longitudinal physiological measurements. Historically, his work has focused on neuroendocrine control and women's health, including demonstrations of pregnancy detection and outcome prediction, neural control of ovulation, and the importance of circadian rhythms in healthy in utero development. Pursuing these and other projects, he has won many awards from NSF, NIH, and private organizations, and has founded relationships with patient communities such as Qualified Self. With the COVID-19 pandemic, he became the technical lead on TempPredict, global collaboration combining physiological data, symptom reports, and diagnostic testing, seeking to build data models capable of early onset detection, severity prediction, and recovery monitoring. And we are going to hear from Ben today on overcoming algorithmic biases during COVID and beyond. So take it away, Ben.
Thanks, Kyle. I'm really glad to be here. And I guess unlike Zoom, this thing doesn't give me a little pip. So are you looking at my presenter slides, or are you looking at my, the preview of the next slide?
We are seeing your presenter version.
The full version, that is.
We're seeing your presenter panel.
Okay, let me just unhook my second monitor and see if that solves the problem for us. Every system's got to be different, right?
Yeah, it's definitely the
okay,
fun.
How about that now?
Yeah, that looks better.
Cool. So hi, everybody. Technical stuff aside, it's a pleasure to be here. I joined UCSD and HDSI about a year ago in March. Everything shut down when I joined, so I still don't have an office. But it turns out that's all right, because I'm just doing data science instead of wet lab. But for context, the things that I had done in the past were very much biological time series data generation. So in animals and humans, anything that you want to measure, whether it's cholesterol or your temperature or your steps or your sleep, some blood measure, all of those things are changing both across a day, so with a daily rhythm, across a year, seasonally, if you're a woman who is cycling, of course, then across a month, and for most of us within a day as well, what's called an ultradian rhythm. And ultradian rhythms are within a day rhythms. They're tied to hormonal changes, but they show up in changes of other things affected by hormones, for example, your heart rate or your temperature. And so what my work seeks to do is understand not just what is the value of a single measurement, your temperature at any one random time, but the shape of those changes that signal processing reveals as these data become able to be attained continuously. And so I use a lot of wearable devices in my work. So when I joined, all of that pivoted into COVID, and we launched this study called TempPredict. This is in collaboration with UCSF, doing clinical work, myself and a wonderful team here at UCSD that I got to work with, leading the technical side, and then Aura, which is a wearable device company, and they acted as sort of a good faith conduit. So users that already had an Aura ring could join our study and donate data. And from that, we generated about 64,000 eligible participants. Actually, close to 100,000 reached out, which was really nice. Of course, as I just said, UCSF was then managing all of the patient load, reaching out to hospitals where we were able to donate about 4,000 rings, get medical first responders involved, running several thousand, about 20,000 antibody tests actually in the end. DoD eventually got involved and was funding some of this effort, and then brought in with them MIT Lincoln Lab, who has been a really good collaborator. So to give you a sense of what do these time series data look like that we're talking about, this is just one patient. And so what you can see here is temperature, heart rate variability, respiration rate, and then across the X is many, many weeks, dates. What I've highlighted in red is that time during which this person reports feeling sick. And so you see in blue, for example, at the very top graph in temperature, all of these humps, each of those is one of these daily rhythms that I was talking about. And you can see that that changes temperature very substantially, but that we're able to see this big elevation around a fever. So we were able to publish that course, you can use these wearable devices to, in fact, classify sickness events like fever very nicely, which had not been shown previously. And you can combine these, and this is just one excursion variable as an example, but you can imagine there's lots of ways to mathematically combine all of these features, or all of these data streams rather, into features that tell you, is this person probably sick or not? And in fact, they start to rise a lot of the time before the person reports a sickness. And so early on, that was what gave us confidence that we would be able to build some algorithms for early detection of onset of illness, and not just, hey, by the way, you're sick and you already know it, but get ahead of that. And I'll show you a little bit about that later. One thing I want to show with this person, though, is a lot of our effort initially was early detection, and we finished a clinical trial in April, and that's been going very well. But if you notice from this excursion variable, this person stays pretty noisy long after they say they feel better, after the red ends. And if we do some signal processing like I was talking about, in this case a wavelet decomposition, we get a frequency space instead of a linear value space. That looks something like this. So now we have frequency on the y-axis, the same times across the x-axis. And at the top where it turns all yellow when they get sick, that's in the range of sort of 12 to 24 hours. So it's these longer waves. And what you notice is that this person, before they're sick, has a sort of a green-blue profile. After they get sick, they stay yellow. And in fact, we see this in a lot of people for months, in fact, until we run out of data at the end of 2020. So what that's telling us is that we believe we can use these wearable devices not only to detect illness onset early, but actually to start to screen for, in this case, COVID long haul. But of course, I don't believe that this is particular to COVID. So I think this is really interesting, thinking about all kinds of both preventive healthcare use and chronic condition monitoring. These wearable devices really let us tell within an individual, when have they gone through some sort of state change, and has that resolved or not? So that's very exciting to us. We were able to serve real-time alerts to people because at SDSC, the supercomputer center here, working with HDSI, Ilkay Tintes and her team were able to work with me to build some novel cyber infrastructure. And I won't belabor all of this, but the point is we're able to ingest external data. We're able to put that into a searchable, secure timescale DB structure, de-identify it for the purposes of then being able to open it up, share it to collaborators and analysts in the Pacific Research Platform in Nautilus. And that's extensible, which means that we can handle sort of almost arbitrarily large data sets, which is why we're able to then analyze tens of thousands of people, even though we have measurements in the case of heart rate every second. Lots of different functionalities built into this, so that we're trying to build as many tools in as possible to allow researchers to explore rapidly, find the patterns that might be useful, and then implement those algorithmically. Local storage and persistent volumes for people that want to come back or share labs. And what this allowed us to do was ingest multiple types of data and develop algorithms for early detection, as I mentioned. So this is a look at a different kind of data. These same people were filling out demographic surveys, surveys about stress, alcohol consumption, things that we've heard about, and then every day, symptom surveys to tell us what were they feeling. And so we were able to, talented undergraduate, Amit Klein, from bioinformatics, has built some Bayes nets to start to classify different symptom clusters. So here we're looking at, for example, how do you differentiate somebody with flu from somebody with COVID based on their symptom distributions? Combining these, we're able to say, when is somebody reporting sickness? When are we seeing changes in their physiology? And how do we combine that to train machine learning algorithms for early detection? This is a model that we have many models. This is one of them that we had deployed. PX here, basically what this means is on average 1 to 2 days before the person is reporting symptoms. And you can see that overall the accuracy is in the mid-80s, which tends to be the case across the model, so that's very good. And you can also see that we can track the relevance of different kinds of modalities. So of course, different wearables as they continue to come out have different sensor packages on them. And so one of the important things I think is being able to say which of those contains what kind of information. So here we see performance without heart rate, performance without temperature, adding these pieces of information across modalities. And as that space continues to evolve, being able to understand the information these different channels give us is very important. There's one other thing that's a big barrier to this being a solution to COVID and all kinds of health problems. And that's that these algorithms, even though they look numerically impressive, they fail to generalize. So, and this is something that affects everybody in the space. People are substantially different from each other. And so it's not enough to have a good algorithm. What I've become convinced of through this experience is we really need to understand physiological diversity with the same kind of depth that we understand genetic diversity, in the way that that helps us develop treatments, target interventions, and differentiate individuals. So to give you a sense of that physiological diversity that I'm talking about, this is just looking at the first 50 people from our study on the left. I'll focus there for a minute. This is looking at their temperature average and range. And you can see that people are quite different, even in something that we think of canonically as stable temperature. Everybody is supposed to be in Fahrenheit 98.6. Clearly, that's not the case. Some people are colder, some people are hotter. And as I've shown you, even within a person, you're changing across the day very substantially. And so any one threshold in a hospital, 100.4 degrees is a fever. It doesn't hold for everybody. And even for anybody it does hold for, it doesn't hold at all times of day. So we really want that within individual dynamic measure to compare to. Heart rate, of course, you can imagine, an athlete versus somebody who's maybe not an athlete or even has metabolic disease. And of course, there's a very large range of resting normal heart rate. So it's not just, though, that you have a different value, right? Maybe I'm hotter than you are on average or something like that. But there are all of these different scales of rhythm overlapping. So biologically, we discussed a number of time scales. Here we're seeing that comparing about 20,000 people, everybody in this population shows a yearly rhythm, seasonality. So here we have night length in red, and here in the southern hemisphere on the bottom, and you see that they're inverse of each other, that people in the northern hemisphere have this rhythm of resting heart rate that's tracking the seasons. What you also see is all of these spikes, and those are weeks. Now, there's not a biological rhythm, which is 7 days. That's social. So what we're seeing is the imposition of, for example, the work schedule, work week, on top of these biological rhythms. But that affects people differently, depending on how you're employed, depending on how you spend your weekends, depending on, again, whether you have cycles of a monthly scale overlapping these if you're a cycling female. So again, any one pattern is not going to fit everybody. And early on, we realized we were going to alert a lot of people to sickness every Friday night because they would have this heart rate spike, and we needed to do better than that. And so figuring out how do we find these rhythms, which biological modalities do they manifest in, and for whom is what a regular pattern, who has a strong weekly pattern, strong monthly pattern, and how do we know an outlier for them rather than in general, is I think a really important direction as we move forward. Physiological diversity, adding that layer of complexity. So this is all in service of sort of a vision of being able to build smart public health, but that's actionable for individuals. So this is, an example I showed you of finding a fever in an individual from their temperature data. You see these big daily rhythms, and then you see you can extract a fever quite nicely. And that's compared to what we do in public health, which is county level aggregate data, which we're seeing here, a map that Davis had generated a number of months ago. And the idea is, because commercially available wearables are on millions of people, if there was a safe, maybe publicly regulated way of aggregating those data for people that want to participate as tracer particles, you could imagine building a sort of a weather radar where you're able to figure out in real time where are fevers emerging, where are different kinds of sickness emerging. Are people in Flint, Michigan all of a sudden looking funny, and should we go investigate before years have passed? So this is a cartoon, not real data, but hopefully gives a sense of the kind of thing that I think is technically possible that we're trying to develop now. And of course, I just want to give a plug and say I think San Diego is the place to do this, because there's this incredible number of partners that we have. And of course, this is not an exhaustive list that make this kind of thing actually, I think, reasonably near to hand, although a substantial amount of work to do. So with that, I'll just say thanks very much for letting me join. I want to thank, of course, people in my lab that led some of the analyses I showed you, people at UCSF doing the clinical work and management, people at MIT Lincoln Lab that have helped with the algorithm design that we've been deploying, and of course, once again, UCSD colleagues, especially Ilkay and her team, Sandeep managing security, that have done a tremendously good job of enabling this. And so with that, I will see if I'm able to stop sharing screen. I think there I go. You see me again now?
Yes, yep, we see you, Ben. Thank you so much for that interesting talk, and it's interesting to see how COVID is causing us to kind of look at things differently that, as you point out, may not be particular to COVID, but just a different way of looking at things. So thank you very much for that talk, and we will have a Q&A after our final speaker, so we'll see you again. So appreciate that. And let's see, we're going to transition now. So our fourth faculty lightning talk is going to come from Dr. Uma Karmakar. She is an assistant professor of marketing and ITO at the Rady School of Management, and will be giving a presentation entitled Add to Cart, the Impact of Display Items on Purchase Decision. Uma's research examines the factors that consciously and unconsciously influence how people make decisions, and the ensuing implications for marketplace practices. In particular, she looks at how people use their information or incomplete information when they are faced with uncertain decisions and unfamiliar options, and the biases that can emerge from these situations. Her work also explores the ways in which companies' decisions about how and when to offer information can frame consumers' expectations and influence their purchase behavior. This research takes an interdisciplinary approach combining marketing, behavioral economics, neuroscience, and psychology. Her work aims to enable firms to communicate better with their customers and improving consumer confidence and satisfaction with the decision process. Before joining Rady School, Karmakar was an associate professor of marketing at Harvard Business School and spent a year as a visiting professor at the Haas School of Business at UC Berkeley. So I will now turn it over to Uma. Thank you so much for joining us today. We look forward to hearing your talk. Oh, and just a reminder, please use the question feature for all attendees, and I will field those at the end.
Thank you. Can everyone hear me?
Yes, we can.
Okay. Someone, you'll probably need to let me know as well. Can you see the first slide?
Yep, looks good.
Excellent. So tell me when I've embarrassingly shown photos of my background or my child by accident. Thank you so much for having me. I will actually, it seems like, be giving a qualitatively slightly different kind of presentation. I will be talking about a particular application of data science, but in reality, while I will give one example from a particular project, what I'm really doing today is giving a little bit of a mention on some of the ways that we use eye tracking to look at customer insights, and why that data is exciting and interesting and in many ways complementary to some of the other forms of data that my colleagues have beautifully demonstrated today. In fact, I have sort of simplified a lot of the analysis in my presentation, and now I'm feeling jealous that I don't have those really beautiful data visualization slides to compete with. But fundamentally, what motivates my research in general, and again, my training, I'm a neuroeconomist, so my training is both neuroscience and business and marketing related. As a neuroeconomist, as a psychologist, as a neuroscientist, it's always a bit shocking to me how complicated it is in terms of the setting of where we make decisions. So I know that we're all used to going to the grocery store, maybe a little less frequently these days than we used to be, but if we think about it in the context of psychology or neuroscience, this is an astonishing amount of information. It's actually amazing that we're capable of navigating such an information-rich space. Every insight and research study that's ever been done suggests that every piece of information here is screaming messages and different types of decision influences at us. We see apples up front here, and we see the red delicious next to the Granny Smith. Plenty of marketing studies would claim that you would buy those apples differently if they were next to the oranges or next to the vegetables or even in the refrigerator with the milk. So there are all kinds of factors going on, and somehow we are processing all this information in a way that seems effortless. Nobody really has that much trouble popping into the store to grab an apple. Now, you may say, well, it's been a while since we've been in the grocery store, and the reality is that things are no less dense when we shop online. So if I want to buy my kid a game like Bananagrams online, I can very specifically and cleverly manage to navigate to a particular page. And notice that as a consumer, my only decision is actually very simple here. Add to cart, yes or no. I'm here, I'm looking at Bananagrams, I have all the information that I need about Bananagrams, and all I have to do is say, yes, I want to buy this, or no, and I want to move on. And there's all this information again, but in addition to that, it's not as if we are shopping in isolation here. The store's algorithm or recommendation system is probably going to tell me about a lot of other stuff. So even in this quote unquote reduced online atmosphere, we still have information about all kinds of other products. We have a display that the Bananagrams are featured in. So as I mentioned, it's amazing to us in general as consumers, and it's amazing to me as a researcher, and it should be amazing to us in general as consumers, that we make these decisions in a reasonably comfortable way. And the question is, how much do all these extra things matter? And so one point that you could make, particularly in the current audience, is doesn't big data or sales data already take care of our understanding of this complexity, right? Like we know what people buy, we can gather their behavior over time. It's not to say that things aren't complicated, but we have ways of addressing this with the metrics that marketing commonly already uses. And my answer would be sort of, but perhaps not entirely. So this is data from an eye tracker. It's one person who's making a shopping decision on a website where they're going to buy jeans. And it's a heat map, which basically just means that the darker the red color, the longer they looked at a particular item. Now, the arrow in red shows you that they bought the second pair of jeans. It's the thing that they looked at the most. They looked at the jeans and they looked at some information about what it was, probably Levi's, maybe something about the price. Sales data would completely capture this. It would tell us that this is what they bought. What it might not capture is the fact that they looked at other options on the page and which options they looked at and which they didn't, which is all part of that decision environment where they're making these choices and could influence not only the choice they made this time, but the kinds of choices they might make in the future and how they think about the store and how happy or unhappy they are with the jeans they ended up buying. So you'll note that they looked at some of the general information about shopping, and they also looked at the jeans on the left and the right of the ones that they eventually chose, and maybe not as much on the one all the way to the right, or not as much in terms of scrolling down. So there's a lot of density of information here that isn't necessarily captured by all of the types of metrics and data that we normally capture in our sales, revenue, purchase, even click-through types of data. And that's where I think some of the benefits of psychological measures, consumer neuroscience measures, but also specifically eye tracking come in, because there is data in what we don't see and in what we do see that we might be missing. So eye tracking offers rich, high-dimensional data sets that create a more flexible understanding of consumer behavior. And as an experimentalist, I guess I'm lucky that it's beautifully suited to a massive form of rise in e-commerce, that we shop on screens, and that's one of the best places to do some of these experiments. Although I should say that eye tracking glasses can be put on people's heads and have taken with them when they go into stores. Fundamentally, the density of this data helps us handle the fact that these things are complicated. It gives us new insights into the way that people make decisions over space and time. So let me give you just a teeny, ultra simple example from my own research related to this add to cart question. Bananagrams, yes or no? As I mentioned, the algorithm for the store is probably going to give me some other things that I might want to buy. They maybe know that I have a kid at this point based on my shopping patterns. In fact, they might give me other games that I could buy. But they might also notice that, again, if it's Halloween, let's say, if I have a kid, I might be interested in other stuff that the store sells. So they may choose to cross-promote things like Halloween costumes. And my fundamental question is, does any of that matter? Right? So from the perspective of the store, they just say, okay, she's buying this. And then as a secondary decision, we could either have her look at these other items, or we could have her look at a different kind of item. But they're treating, often these algorithms are treating the decisions as two separate things. You are going to buy bananagrams, yes or no. And then you may also be interested in shopping some of this other stuff. I instead want to propose that by looking at this question a little more carefully, we could see whether the things that they offer, the display that the bananagrams are in, actually changes our likelihood of buying bananagrams in the first place. So I ran first a very simple behavioral experiment. This is not the place where the data science necessarily pops in its most sophisticated level. I just gave people shopping decisions. And sometimes they saw bananagrams by themselves, sometimes they saw it in a display with other types of games, other things from the same category or matched. And sometimes they saw a product with other items that the store sold, but not from the same category. And what I found was that when the items were matched, that is when bananagrams was with other games, people actually bought the game more often. They were more likely to buy the game, even when they were spending real money. They would do this, so they would do it when they just thought about whether they'd buy the game, but they would do this even when I gave them money to spend on it. When it was, in fact, when the display items were from other categories, other pen knives and candles and sheets and bath towels, that actually decreased the likelihood of buying bananagrams. So the display that an item is embedded in changes your likelihood of buying the item, even when there's really only one button to click on the screen, add to cart. Now, you might imagine there were retailers who were particularly interested in this because the way you design your recommender system is around several strategic goals. And it would be interesting to know whether the things that seem like they could compete, other games, are actually enhancing purchase compared to presenting the item alone. But what I couldn't tell them with this is why it was happening. Because if you want to design those systems and you want to think about what kinds of data you want to get, you want to know whether people were paying more or less attention to something. Did they care more? Does including other games make you like bananagrams more? Does it make you look at bananagrams for longer? Maybe you think about it more. We know that when we look at things for longer, we are more likely to buy them, and we buy things that we look at longer. So the relationship goes both ways, and it would be nice to know what's happening, because if it's just a question of paying more attention to the target in the center of the screen, we could design our screens differently to get people to pay more attention to it. So to do that, that's where I employed eye tracking. And the data that I'll show you is from only 58 people who made 36 decisions each, but the dimensionality of this data comes from the fact that it's recorded over 10 minutes with an eye tracker that captures samples every 16 milliseconds. So it's actually a low-end 60 hertz eye tracker. We at Rady have just acquired a 600 hertz eye tracker to be used in this kind of research. So there are up to 36,000 data points per each person, and they reflect something spatial, that is where the person's looking at on the screen in an XY dimension, and also temporal, a timestamp of where all of this data is coming from. And to analyze this particular data, I used a fixation classification algorithm, which basically says, how long does someone have to be looking in one place for us to count it as them paying attention to that thing? So we're going to count the length of looking, or the duration of looking, is the total fixations on that, when your eyes are paying attention, basically. And the first thing I looked at was the question that all these retailers were asking me. Are people just looking more at bananagrams when the other items are similar to bananagrams? So to do that, I captured all the times that people's eyes were in these boxes. So Sally mentioned the importance of experiments to design causality. Here, I wasn't looking afterwards to see what the heat maps looked like. I actually drew a box around these things and said, okay, anytime the eye tracker picks up a fixation, a sample in this space, I'm going to count it as paying attention to something related to bananagrams. And what I found is that there's really no difference in how much time you pay attention to the thing you're thinking about buying, regardless of what's going on in the display. So at some level, our assumption about the target is right. That is, you pay attention to the target the same, regardless of what's going on in the display. So why did the display change the purchase decisions then? I mean, the target was the same across all these conditions. Well, it turns out that you can also look at how much people looked at the display items. And that's where that difference is. The mismatched display items, the ones from different categories, were stealing more of people's attention. And again, I sadly haven't shown you all the cool computational models and graphs that lead up to these kinds of conclusions, but fundamentally, we are more likely to buy things that we look at longer, and we look at things that we want to buy for longer, and we assign more value to things that we look at longer in consumer product decisions. So when we look at the mismatched display items longer, it's not so much that we're decreasing the value of the target, we're increasing the value of buying something else, which decreases our likelihood of buying the target. So we like bananagrams the same, but it's not as great in the total amount of stuff we could be buying. Now, again, this is just one tiny little example. Eye tracking data, as I've mentioned, has incredible dimensionality that looks at what you see and what you don't see. So if we take a look at the levels of data we can analyze, here's an example from someone just looking at an advertisement without necessarily classifying those boxes ahead of time in terms of what the different fixations mean. The bigger circles are things that they looked at longer, the smaller circles are things that they looked at for less time, but you can also see that you could also look at the track of where they looked. What did they compare between? Where did they go back and forth with their eyes? In ways that are, again, at a millisecond timescale, so way faster than people would be able to tell you by self-report. Fundamentally, eye tracking represents millisecond level detection of eye location and by proxy, attention and engagement in information. It supports exploratory research like this one, where you just show people things and see where they look, and experimental studies like mine, where I had predictions about how I was going to classify where they looked ahead of time. The dimensionality of the data makes it useful for pattern detection, qualitative classification of new categories of interest, as well as for generating massive training data for AI and neural net prediction models. So there's a lot of flexibility in what we can do. And again, the data I showed you was just a quick summary of what you can get from a 60 Hertz, very easily available commercial eye tracker. When you do this at the research scale with 600 Hertz, you're literally collecting data every 2 seconds, or every 2 milliseconds, I'm sorry. And human beings are capable of making decisions on a scale of 200 to 300 milliseconds straightforwardly. So what I want to finish with is that eye tracking is one piece of a larger suite of what I would call the neuroeconomics or consumer neuroscience toolbox, which reflects the fact that consumer decisions and real marketplace decisions unfold over both time and space. Neurobehavioral methods, therefore, can be used to capture multiple dimensions of these choices. We can generate huge amounts of data that have all these different dimensions through things like eye tracking or brain scanning techniques like functional magnetic imaging, which I also do, in addition to a number of other techniques that are available now in the marketplace as well as in academic settings like electroencephalography, facial and motion coding, biometrics, and of course, melding these with behavioral data sets to create convergent representations of the decision process. Complementing these measurement techniques are the analytics techniques that integrating neuroscience brings into the party. We have both statistical and computational models based on an understanding of brain and mind that elevate the interpretation of these multidimensional data sets when we get them. With that said, I really appreciate the opportunity to speak to you all about some of these advances. I look forward to any questions, and thank you very much to both those of you attending and to the organizers.
Thank you so much, Uma. That was really a great talk, and it's, you know, obviously we are not in your field, but we're all consumers, so it's just fascinating to hear sometimes about how many of those decisions just happen subconsciously, and really enlightening talk. And so I'm sure we'll have some good questions for you later on. Really appreciate it. All right, I'm going to transition to our fifth and final faculty speaker at this time. Arun Kumar is, Dr. Arun Kumar is an assistant professor of computer science and engineering at HDSI. He is a member of the Database Lab and Center for Networked Systems, and an affiliate member of the AI Group. His primary research interests are in data management and systems for machine learning, artificial intelligence-based data, and artificial intelligence-based data analytics. Systems and ideas based on his research have been released as part of the Apache MATLAB open source library, shipped as part of products from Cloudera, IBM, Oracle, and Pivotal, and used internally by Facebook, Google, Logic Blocks, Microsoft, and other companies. He is a recipient of 2 SIGMOD Research Paper Awards, a SIGMOD Research Highlight Award, 3 Distinguished Reviewer Awards from SIGMOD VLDB, and the PhD Dissertation Award from University of Wisconsin-Madison in Computer Science, the IEEE TCD Rising Star Award, and NSF Career Award, a Hellman Fellowship, a UCSD STEM Faculty of the Year Award, and Research Award gifts from Amazon, Google, Oracle, and VMware. So certainly an impressive resume of work. And Arun, if you are ready to turn on your webcam, we will look forward to your talk.
Hey, Carl, thank you for the introduction, and thank you for having me. It doesn't seem like my webcam is working on this GoToWebinar platform. It's asking me to allow system preferences, but it doesn't show it. I don't know why. Let me see if I can share my screen. Am I audible?
We see your screen. We just don't see you, I believe. Or no, is that Sarah's screen that we're seeing?
That is not my screen.
Yeah.
Okay, so let me see Keynote. There we go. Okay, so now it's asking me to show this window. Can you see my screen?
Yes.
Wonderful. Somehow it seems like my webcam is not working. Sorry about that. Okay, should we just get started then?
Sure, go ahead.
Okay, so let me.
Unless, I mean, Sarah, do you have any insight on maybe that setting issue?
He needed to provide permission before the event to his security preferences.
Okay.
Unfortunately, it's too late now.
Okay, we'll get started.
Oh no, sorry about that. I mean, it asked me for the mic and the webcam. The mic seems to have worked, but the webcam didn't work. That's weird. Okay, let's get started. Hello everyone, and thank you for coming to this talk, and thank you for the opportunity to share about some of my thoughts on systems for data science, from research to practice and back. And as Kyle mentioned, I'm an assistant professor in computer science and in data science. So this is the agenda. Literally, I'm going to talk about systems for data science, then from research to practice, then back. So it's no secret that we are now in the golden age of machine learning-based data analytics. All the big tech companies use machine learning extensively. Almost all of enterprise world wants to kind of adopt machine learning for lots of applications. There's a lot of demand for tools and products to make it easier to integrate ML into data analytics applications, healthcare, finance, retail, insurance, telecom, and also in the academic domains, sciences, and even in the digital humanities. The International Data Corporation, which is a market research firm that studies data software space, estimates that in the next 4 or 5 years, the market size is going to hit almost $500 billion. That figure is astounding to me, but that's what the IDC estimates for software products that enable the use of ML in all these data analytics applications. Naturally, there's a lot of activity here. There's a huge number of really good open source tools that data scientists, ML engineers, all these practitioners like to use. And all the major cloud vendors are clamoring for getting a slice of that pie. And so you see ML AI services being released. Regardless, in spite of all this progress, as I will explain today, there's some numerous fundamental efficiency and usability bottlenecks in the end-to-end process of building and deploying machine learning-based data analytics applications. And that is what my research here at UC San Diego is about. New abstractions, algorithms, and software systems to democratize machine learning-based data analytics from a data management and systems standpoint. And by democratization, I precisely mean the following: improve the system efficiency, reduce the resource costs, resource needs, monetary costs of these processes, and improve the human efficiency, improve the productivity of the people involved in the loop. This involves synthesizing and innovating upon the intersection of the areas of data management and database systems, machine learning and AI algorithms, and straddling the entire software system stack in computing. More concretely, I like to work on building practical and scalable data systems for machine learning analytics. And these are inspired by the principles of one of the most successful examples of data software, which is relational database systems that we have been studying for half a century. But it also exploits mathematical insights from statistical and computational learning theory and optimization theory that are at the root of what machine learning computations are about. I have interacted with over 36 data practitioners, data scientists, machine learning engineers, data analysts, business analysts, domain scientists, and many others in various enterprise, web, healthcare, and academic settings. And based on my conversations, I distill the end-to-end life cycle of ML-based applications into the following 3 stages: source, build, and deploy. Source basically requires these people to convert the raw data in their repositories, the multi-table relational databases, text corpora, images, time series, multimedia, convert them into a form that is ready for ML to be applied. Build is the process of model selection where you convert that ML-ready data into a prediction function or pipeline by applying things like algorithm selection, hyperparameter tuning, feature engineering, and so on. And the last one is deploy. Once you have a prediction pipeline, you have to integrate it back into the application that provided the data. And that could take the form of integrating it with a DBMS or just presenting it to your boss or plugging it into a cloud service for, say, web companies. All of this, the data scientist or the ML engineer needs to monitor and maintain over time as the application evolves, as the data evolves, and so the models must also evolve. And across the board, they use data systems and ML systems to achieve their goals for their application. Now, based on my conversations, I identify bottlenecks in this end-to-end lifecycle. I abstract the key steps, formalize the computation from a computing standpoint, and this allows me to automate a lot of manual grunt work that still permeates this lifecycle. I don't know if you've seen surveys of data scientists that show about 80 to 90% of their time often is spent on data grunt work, not on ML algorithmics. And so how do we automate some of this grunt work in an efficient and robust manner? That's part of my research. And now that we have formalized the computations of these steps, we can automate and optimize these computations using techniques from the database and systems world. And that is a lot of what my research is about, optimizing the computations of end-to-end ML workflows. If you want more specifics about my projects, feel free to go visit my research group website, adalabucsd.github.io. We have all our projects and papers and blog posts about them also listed there. What I will share today is one particular story from my research, where we went from basic research to working with practitioners and then back to how it helps advance basic research again. And I hope this story is of interest to this audience. I spoke with Eric and Kyle, and they said this could be potentially useful. So this is the first time I'm giving this. If something is not clear, feel free to ask me in the Q&A. Okay, so why bother transitioning research to practice? I am an academic. I have to publish top-tier publications. So why should I bother with transitioning into practice when most of academia still only bases its evaluations on publications? Well, it helps me amplify my impact on the world. And by mine, I really mean my students, because they're the ones who are leading a lot of these projects. And that is satisfactory for us. It makes us feel happy when we see our tools, our software get used by practitioners, not only in the commercial world, but also in the scientific world. In turn, and this is something that not many people notice, is you can identify new research gaps. Based on what the practitioners do, based on the lessons from how they use these things, you can identify new open questions. And that is something that has happened repeatedly in my work. Perhaps also rake in some money, like funding, grants, gifts, whatever. I'm only half joking about it. Okay, so the case study I'm going to share today is about this line of work on model selection systems that I've been pursuing for 5-6 years now. The focus is on deep learning here. TensorFlow and PyTorch, all these tools that the software industry has released, has really revolutionized the way people build predictive data analytics applications in many settings. Deep learning is very flexible. You can convert virtually any form of input to any form of output. However, there is an Achilles heel. The Achilles heel for deep learning is model selection. Every time you build a deep learning model, you have to train and compare numerous related configurations, changing the data representation, changing the neural architecture, changing the hyperparameters, and so on. All of that can amplify your resource needs sometimes by even 100 times. And these companies, these Googles and Facebooks of the world, Their solution is to just throw more and more GPUs at it, which is probably not affordable for the rest of the world. Now, this focus on model selection management systems was the centerpiece of my vision in my job talk. That's a screenshot from my UCSD job talk. Turns out it panned out even more successfully than I thought it would. So thank you, UCSD, for allowing me to do this sort of work. So this was basic research. This was born out of research paper that I published in 2015, the year before I went onto the market. What did I do after coming to UCSD? I looked for people who had valuable data and scalability problems and systems problems. And so I reached out, actually no, people in this medical school reached out to me after seeing that I joined UCSD CSE, and their goal was to predict sedentary behavior from accelerometer time series data. And these were people who were faculty there, who were researchers there. Some of them are now in the public health school. We have a separate school now. And they had almost 800 gigabytes of label data from an NIH-funded project. And they were basically trying to predict from accelerometers whether people are sitting or standing, what's their exercise activity. They were using this for understanding longitudinal kind of behaviors and health impacts of people from various cohorts, people who are cancer survivors, people with obesity, people in assisted living facilities, and so on. And so the goal of this machine learning problem was to build a model that will take the time series input and predict the activity. They had a random forest model that involved very heavy duty featurization time series stuff, and that gave about 76% accuracy. We helped them out over the course of the last few years, and now we have produced large-scale deep learning models trained using the system that I'll talk about that has boosted that accuracy to almost 92%. And that sort of a lift is very rare to hear in the machine learning world. And this model, as I'll say later, will basically be the state of the art for this task. So what was the key bottleneck that I realized from this interaction? I realized that the key bottleneck was model selection. We needed higher throughput to compare multiple models without wasting a lot of resources, without wasting a lot of runtime. And I observed that the prior art for deep learning training went somewhat like this. And this is a cartoon diagram. The data scientist specifies the deep learning task, and then the system runs it on the cluster. You have GPU, CPU, memory, and so on. It runs it one model at a time. In Project Cerebro, we looked at it more holistically and then said, well, actually, you're specifying not just one training task, you're specifying a model selection task. Compare multiple neural architectures, hyperparameters, and all of these things. And instead of the system directly placing it on the cluster, we intercept it in Cerebro using a middleware layer that uses what we call multi-query optimization. That's technical jargon, I won't go into too much details. From the database world, what it does is it automatically rewrites the computations in a way that makes it more efficient, more resource efficient. Runtimes go down, storage and memory requirements go down, network costs go down. And so now, instead of the user manually handling hardware, they handle it at a higher level of abstraction, and our system executes for them in a more efficient manner. This sort of decoupling is a fundamental philosophy in the database world. The what of the computation is decoupled from the how of the execution. And this is the first project to bring this sort of a notion of system design to the machine learning systems world, specifically the deep learning world. This also allows us to run Cerebro in all other environments, not just on plain clusters on campus, but also in cloud native environment, in a Spark kind of cluster environment, with the same piece of code that they specify. And this sort of generality was not heard of in the deep learning world before this sort of project. Okay, so that's the research snapshot. It turns out that this led to state-of-the-art results in the computing world for all key system efficiency metrics, runtime, memory storage, network cost, and ML accuracy metrics on benchmark tasks and datasets against the best-of-breed open source and industrial toolkits. And we published this at top-tier conferences, VLDB, CIDR, these are like top-tier data management and database and data systems conferences. In collaboration with our public health colleagues, we produced deep learning models using our system that led to state-of-the-art results for that particular task that a lot of groups across the country and across the world study. And thankfully, that also got published at a public health journal, and we were happy to co-author it with them. And the models have been open sourced. It is now being used by other researchers at other universities to try it out on their data. We are also applying it to new cohorts from Kansas, from Australia, and all over the world, where these models can be applied to analyze their sedentary behaviors. And over the last 4 years or so, this project has managed to attract a lot of funding, and I'm really fortunate for this. The Hellman Fellowship, very generous. I'm really glad that program exists for UC faculty. My colleagues in the public health space roped me into this NIH grant, and NIH approved it. So I was a co-PI of an NIH grant, which I never expected to be. I wrote my NSF career proposal on this project. It got funded, and my collaborator in the public health space gave me a support letter for this, and the reviewers are pretty happy to see this sort of cross-disciplinary collaboration. And more recently, VMware, a software company, cloud company, funded this with a generous unrestricted gift as well, because they realized that the importance of efficiency and resource efficiency in deep learning is only going to grow. Practically speaking, we actually found interest in the software industry as well. VMware's Apache MATLAB team adopted some of the ideas and code from Cerebro into their open source in RDBMS analytics tool. So basically your data sits in your relational database system, large scale, like terabytes, hundreds of terabytes. You don't need to export and move it around. Deep learning algorithms will come to the DBMS process space. And they have open sourced this, it's up on their website. They actually cite our research paper in talking about the implementation. And they are actually putting this software in front of their enterprise customers. And they've been talking to people who are interested in natural language processing, computer vision, and all these other multimodal analytics applications in the enterprise space. So this is something that we were able to achieve while sitting in academia without needing to start a company, without needing to go through all the rigmarole of hiring people and funding and all of that. Somebody else is doing all that work for us while we get to focus on what we enjoy the most. That's a pretty cool model. And VMware was pretty happy with that. And they also presented our work at an open source tools popular industry conference. This is their speaker, Frank, our collaborator. He acknowledged the collaboration with UC San Diego. We also integrated this with Apache Spark, another open source data platform. And my students presented it at another popular industry conference, Spark AI Summit last year. This was one of, I think, only a couple of academic research-based talks at the Spark AI Summit, where almost a couple of hundred industry speakers show up. And the only other academic speaker was from Mate Zaharia's group, who's the founder of Databricks and creator of Spark. So it was pretty cool. So that's all from research to practice. How does it help us to do all this? What I found was in applying these sorts of technology to these problems, many of these practitioners, they tend to have this mindset of, okay, we have done that now. Now let's see something else that we can do, something more that we can do. They start dreaming bigger. They start wanting more stuff. And that's good news because it establishes a virtuous cycle for research and practice. And so here, for example, in the time series analytics task, we realized that transfer learning has not really been studied seriously. Transfer learning is something that in the deep learning world is front and center for image and text tasks, but not so much for time series. And we realized that based on the models we're using, there is some potential here. And the key benefit of doing this is reducing the amount of label data that you need and reducing the amount of resources in turn. And so the public health folks are excited about this. This is the first time this is going to be brought to this domain. And we are hoping to write an NIH grant in the near future about this. We have some prior experience with basic research on building scalable systems for transfer learning. And that also appeared at SIGMOD last year. And that expertise can be brought to bear in this meaningful public health setting. VMware, we continued collaborating with the MATLAB team. We realized that there's a larger Pareto frontier of trade-offs, not just runtime efficiency, but also usability, portability, developability, and so on. And we characterized this trade-off space in new research that followed up. This is the first time such a space has been characterized for scalable machine learning analytics systems. And the hope is database systems vendors like Oracle and Teradata and Amazon, cloud vendors can benefit from it, and they can create more seamless experiences for their customers to bring machine learning and deep learning to their databases. And this paper is close to being accepted at VLDB. It's under revision. And you can see there's a bunch of authors from VMware as well on this paper. And we hope to continue this collaboration on the transfer learning side, on many other things that we published about on Project Cerebro. And this is not the only story. I have more such stories. If you give me more time, I will keep talking about it, but probably I should stop talking about it. Statistical machine learning methods over multi-table data. That's something I've been working on for a few years. We published a basic research paper at VLDB, and then we presented this at SoCal DB Day, which is an event I helped organize here at San Diego for the Southern California database research groups and industry to show up and chit-chat about research and poster presentations and so on. And the head of Oracle Labs showed up, and he really liked that work. He kind of asked me to submit a proposal. It got funded, and we are now integrated the ideas from that work into Oracle's GraalVM polyglot compiler system, and that also appeared at that is going to appear at VLDB conference this year. So research to practice, back to research. Same thing on another project on automated data preparation on automated machine learning platforms. There was some basic research, including actually learning theoretic research that we were doing in 2018 that got picked up by Google, and they were interested in it. They gave me a research gift for this. NSF, there is a search system that I'm part of. That's a Convergence Accelerator grant. They were interested in this. Most recently, Amazon Web Services, their SageMaker Autopilot team and other machine learning platform teams are also interested in this. And we've been collaborating with Google for a couple of years now. Our new paper on benchmarking automated data prep came out this year. It's going to appear at Sigma this year. And we're hoping to expand our collaboration with various domain science teams that NSF put us in touch with to apply these ideas in their practice, and also collaborate with AWS and rest of Amazon. So hopefully more such stories in the near future. So to conclude, when building systems for data science, research practice synergy is both feasible and fun. I've had a great time doing all this. It's not just the basic research and advancing science and technology, it's also amplifying the impact of our work, and specifically my students' work, on practice in commercial sector, in domain sciences, and many other spaces. And this in turn helps me identify new research gaps to establish the principles and methods and tools and techniques of this emerging space of systems for data science. And yes, along the way, you can rake in some money via grants and gifts and all these other things. You don't even need to start a company to make this sort of money. That's my opinion. These are the terrific students who have been doing all this work. I'm really fortunate to have these awesome students here at UC San Diego. And with that, I'll conclude. I'd like to thank all my research sponsors. Feel free to go check out the papers, talks, blog posts on our group webpage. Feel free to email me if you have more questions or follow me on Twitter. Thank you. Okay, that's it, Kyle. Any questions?
Yep. Thank you so much, Arun. I really appreciate that, and I think it, you know, this linkage between academia and practice or industry is very relevant to the group we have here today. So much appreciated. I'm going to welcome back all of our faculty lightning round speakers for a brief Q&A section. So if you could all join again on webcam or mic in Arun's case for whatever happened with the webcam there, that would be great. There was also a general question about whether this was being recorded because of you know, the detail in some of your slides, and the answer to that is yes. It will be on the Tech San Diego YouTube channel, and I believe on the Rady and maybe HDSI website as well. So just for anybody wondering about that and wanting to refer back to your slides. But in general, really great presentations. I think each of you in different ways spoke to the applied nature of data science and the ways that the skill set is applicable to industry and also just individual consumers, and in some cases, depending on your talk there. I did want to start, and maybe this is a little more relevant to Ben and Sally, since both of you touched on COVID-related, or had a COVID-related aspect to your talks. And you know, Ben, if you wanted to maybe elaborate a little bit when you were talking about the long haul COVIDers and measuring the illness after the fact, and how that's not necessarily just particular to COVID, but maybe the silver lining of COVID is that it prompted us to look at this in a different way. If you could, you know, maybe just talk about that, and if you see other potential use cases coming out of that.
Sure, thank you. Fundamentally, it just comes down to medicine hasn't had tools to do tracking of an individual over time previously. I mean, certainly not at high resolution. And so medicine has been forced to use population level comparisons, right? Your cholesterol is above this, your thyroid hormone is below this, whatever. Totally impersonal, totally arrhythmic, and so very imprecise, in fact, just the best that was available. All of medicine should be transformed by this. So we've just launched a study into pregnancy, And spoiler alert, you can monitor pregnancy progress, you can monitor complications. Like, your body does these things. If you have a lens that lets you see it, you can see those things. So that's for absolutely every condition that there is in medicine. And I think the big challenge is, as we develop algorithms that find these patterns, making sure that that's really serving everybody, and that it's not like so much of ML in or AI in health these days, trained on people that, frankly look like me, and then applied to everybody else who can afford it, and with less good results or sometimes harmful results. And so that's really a call for much broader social engagement, participant support, privacy support, this kind of thing.
Interesting. Yeah, thank you. And then Sally, related to your study and the COVID impact, I believe I gathered from your talk that originally the study, it began before COVID, right? You couldn't anticipate that. So if you could maybe talk about how that, this unprecedented situation perhaps availed a different way to look at the data and look at your study, and if there's any other follow-on implications of that now prompt a new way of how you want to measure that going forward.
Yeah, connected to what Ben said, I think one thing we found is when you look at health recommendations, it's walk 10,000 steps a day, sleep 7 hours a night, wake up by this time. It's very often about levels. And what we found in our data is that there wasn't such a strong relationship between the level of your activity at baseline and whether you suffered depression during the COVID. It was more about those changes, the changes. And that's why, as Ben was saying, having someone's baseline and being able to track them over time can be really valuable, because whether they're off of their personal baseline. So that's something I think we really learned during the pandemic. And the pandemic was so disruptive that it really overturned sort of people's baseline habits. So for example, one thing we found was that people who are doing a lot of the recommended things, like walking 10,000 steps a day, they actually seem to be at relatively higher risk of having that disrupted during the pandemic. The people who are really active, I think they kind of stayed active because they're the hardcore exercisers. And the people like me who were never doing anything and were already sedentary, nothing changed during COVID. So they weren't that disrupted. And so I think, sort of distinguishing between levels and changes over time, as Ben was talking about, I think is really important. And I'm very excited about this agenda of heterogeneity, which of course data science with enough data can really allow us to take seriously.
Yeah, excellent. Yeah, it's interesting to think about that. If you were already a homebody, then maybe your world wasn't as disrupted. So interesting take. We do have a question from Jeff for Dr. Karmakar. Let's see, let me read this here in the Q&A. And by the way, anybody else wanting to submit questions, do so. We only have a brief time for Q&A. Okay, as the former CTO of Certona Corporation, I'm familiar with recommender systems, and one of the things that we looked at was how recommendations should change depending on where the customer is in the purchase path, such as, a product page versus a checkout page, particularly with respect to presenting complementary or alternative products. And did you happen to look into that effect?
This is so great. And of course, in 10 minutes, totally didn't address it. Yeah, no, that's critical. In many ways, the psychological question that was driving the study just sidestepped part of that completely. So there is, certainly from the people who are designing the algorithms and also from the research side, there is an understanding of this idea of the search path or the decision process, not just in terms of do I buy this, but the broader, am I browsing, am I goal directed, am I buying? In the particular study I showed you, we didn't look at it. The framing in general was much more along the browsing line, the sort of incidental click through, the general display page, the splash page, so less of a goal-directed search process. Implicitly, you are farther down the funnel because you're at the add to cart stage, but the pathway that it took to get you there is implied to be more of a generalized pathway or not necessarily a directed pathway. So I had framed it cutely as I'm looking for a game, but it was really, you know, oh, I saw an ad for bananagrams and click through to look and see. It was much more along that incidental stage. When you do have goal-directed approaches, we've run other studies on this, and actually other labs have replicated this effect. What you find is that there's the same qualitative effect in that, but the directions are a little bit different. That is, for the recommender system, if you offer similar items, you see very little decrease in purchase of the target, and if you add mismatched items, you see a huge decrease when it's, again, a goal-directed search. Whereas in my search, where you're just browsing, similar items actually boost and dissimilar items decrease. So the sort of scope of the effect is that one is, you know, up and one's down, but whether it's actually above just presenting the item alone or below presenting the item alone depends on your question exactly, where they are in the funnel and what kind of approach got them there.
Interesting. Yeah, thank you very much. Yeah, that was a great question from Jeff, by the way. So thank you for that. And just real quick, Uma, in your presentation, you did talk about like this, the vast increase in online shopping and the eye tracking, perhaps giving us a new way of understanding just consumers in general, right? Behavior in general. And I'm wondering, looking at your grocery store image at the beginning of your presentation, how might something like this be extrapolated to an in-person shopping experience? Because obviously you can't rearrange the physical environment as readily as a recommender system, you know, might do. So just curious if you haven't looked, obviously that wasn't necessarily a focus of your study, but just wondering if you have ideas for how this might translate into a physical environment versus
in
on
physical spaces. Yeah.
Mm-hmm.
So the sort of the simpler takeaway is adjacencies or features, right? So you could think of this in the grocery store. You could also think of it in any kind of retail environment. What do you put in the window of the store? What do you put in the impulse aisle? What do you put in the displays? So adjacencies are literally just what product is your product next to. And there's a huge amount of money and energy and time spent on making those decisions. They're effectively interactive design decisions. It's like user interfaces in any kind of a website itself. So it's just in a physical space, and you know, Robbie probably knows better than I do the amount of money and planning that goes into the planogram in the store. So while it may not be taking place every second with every aggregator or Amazon or Macy's or Toys R Us changing this on the second-by-second basis, it does physically happen in the store as well, and those decisions are carefully designed to promote different strategic goals for the firm. And so as a result, you know, some of the implications are that there may be costs to highlighting a particular product in an aisle where it doesn't matter, or promoting a particular product in an aisle where it's unexpected. On the plus side, it pops out as surprising. On the minus side is for someone who's casually encountering it, their attention is being pulled away in many different directions. So what's the cost benefit analysis of putting Frosted Flakes with all the other cereals where it might get overwhelmed versus putting Frosted Flakes, you know, close to the impulse aisle where you may grab it on the way out, but it's also next to chocolate and batteries and everything else that could be dragging your attention away. There are also questions about what it means for the next time that you come to the store, because we encode things that we look at. You know, so attention is intimately related to memory and encoding, and how do we remember this? How do we embed it in our experience? And what do we expect the next time we come through? So this blend of psychology and you know, the way the world works, it offers a lot of exciting insights on how we make choices in noisy situations, not just the clean ones where it's, you know, do you want Frosted Flakes? Yes or no, no other information.
Sure, interesting. Yeah, thank you very much. All right, there's a question from Ronald, it looks like for Sally. I found your study interesting considering how the pandemic has been affecting us all. You spoke on how increasing physical activity did not have a significant effect on mental health, but I was wondering if there were factors outside of increased physical activity that you observed that did happen to have a positive effect on mental health.
Yeah, I mean, it's very complicated, right? And the reasons that people are having these large decreases in exercise aren't necessarily what, it's because people are being forced to be home. I think one thing we realize is that there's a lot of physical activity that isn't going to the gym. It's just walking across campus to your classes, but people aren't going to classes anymore. Or it's walking to the coffee shop to meet your friend, but people aren't going to the coffee shop and they're not meeting their friend. And so is it about the walking, or is it about that when you get to that place, you interact with somebody socially, or along the way you interact with somebody socially? And so I think, what I was trying to emphasize at the end is we can use data techniques to try to tease apart these factors, but of course they interact in really complicated ways. And it can feel frustrating to say, okay, let's run an experiment on 2 weeks of walking. Well, that didn't work. Maybe it needed to be 6 weeks. Let's try that intervention next. Or maybe it needed to be intensive exercise, not just walking 10,000 steps. Let's try that intervention next. Or maybe you needed to walk with a friend. Let's try that intervention next. And so I think it's really tough, right? I think that the data can suggest directions. And then what I wanted to really emphasize is that you shouldn't stop there. You really do need to take that next step, as a lot of the other presenters were showing, of actually running an experiment and seeing if those effects play out the same way that you're seeing the associations in the data. So we are really interested in future directions like longer periods of exercise, more intensive exercise, exercise mixed with social interactions, but there's many. And then I think, of course, understanding maybe it's reverse causality. Maybe what you need to do is actually intervene on mental health directly, and maybe that'll have downstream effects on physical activity. Maybe the reason people aren't exercising is because they're feeling depressed. And I'm really interested, sort of talking about what has COVID opened up, what kind of opportunities. And I think one is this idea of using teletherapy. You hear a lot about telemedicine. Well, teletherapy as well. I'm really interested in the role that that can play in reaching more people, not just during COVID, but even after COVID hopefully ends and we're all back in person again.
Pal, do you mind if I rip off of that?
Go ahead.
Yeah, I think it's great points that you make, Sally. I think one of the opportunities related to that is, and Kyle mentioned this, I work with this group, Quantified Self, sometimes. It's basically just people doing experiments on themselves. But one of the opportunities for data science that I think has blossomed in this last year is people doing it through apps or platforms where the data add up across individuals. And so you end up with these sort of amazing behavior aggregation platforms. And maybe for you it's intensive exercise, and for me it's long walks, whatever. It's going to be different for different people, but starting to build that popcorn from a sort of found art real life experiment to then chase, what was it that linked these people? That's actually a pretty profound new way of being able to do this research.
Interesting. Yeah. Thanks for adding that, Ben. There's actually this is probably going to be our last question, because actually we're coming up to noon here. But I do see one more question in the chat for Ben. Is there anything that you wish the Oura Ring would measure that it doesn't?
Yeah. So, and I had this in my slide, but conflict of interest. I'm a scientific advisor to Oura. I advise them to do lots of things. I think this field of wearable devices is evolving quickly. One of the reasons I really like Oura is they have temperature. More devices are starting to have that, which is great. But it's not like we have enough knowledge to know what's the one magic sensor that would give us the best biological information. We've never had continuous data like this. So just being able to have a diversity of types of sensor, diversity of types of object, where you put it on the body, it turns out makes a big difference. So really, it's not the sensor to me so much as the willingness to share, the willingness to interact with researchers, the willingness to be part of figuring this out. Now, I think one of the missed opportunities of wearable companies in the past was not engaging with, for example, more self-experimenters or more clinical experimenters to say, hey, we have all these data, what do we do with them? What do they actually add up to? Aura's been really good about that. I hope they inspire the market to be more good about that broadly.
All right. Yeah, well, thank you very much. I'm sorry we didn't have questions for all of the faculty members, but we ran out of time. But really great talks from all 5 of you, and I think it just speaks to the broader talent and innovation that's happening on campus, both within HDSI and the Rady School of Management. So thank you all so much for sharing your knowledge with us today. I'll turn it over to Kevin to continue.
Yeah, Kyle, I'm going to do a minor correction. You said they were really good talks. I think they were excellent talks, right? So these were, and the diversity was really, really nice. So I think we chose exactly the right people to give these lightning talks. I want to thank you very much. We'll give you a virtual clap as we do that. Every single one of these talks are fascinating. I want to thank you guys for taking time out of your really busy schedules. And I'm sure we'll be talking to you again. And Kyle, great job on moderating and making sure we got everything we needed out of the lightning talk. So thank you very much. And we'll go on to our next portion of the data science day. We're almost there. I know we say 1:30, but 1:30 was an absolute worst case scenario. We are a little bit ahead of time. We're not going to go to 1:30, I guarantee you, but we are going to go right into our next speaker. We were thinking about a 5-minute break, but we're going to get our logistics set up. So we're probably not going to do a full 5 minutes, but certainly if you need to do what you need to do. But our next one is going to be our keynote speaker, and it's going to tie everything together. And so with the keynote speaker, what I like to do is I like to introduce the sponsor for the keynote speaker. And this is another familiar face, Nik Devereaux. Nik, are you on?
Yes, how's it going?
Yeah, there's Nik. We've seen you before today.
Absolutely. I'm sorry you have to see me twice.
You're supposed to change it now. You're representing Viasat as a sponsor. Do you have a different shirt on, or is that the same exact outfit?
Same one.
Okay. Let's see. I'm going to turn it over to you, and I'm going to let you introduce our keynote address.
Awesome. Be right back. I'm going to actually Google Witcher Season 2 now that I'm inspired by the background. It's my pleasure to introduce Jeffrey Yao. Jeffrey is a local living in San Diego. He works at the Store Associate Technology Organization within Walmart Global Technology, formerly known as Walmart Labs. They're our corporate neighbor up here in Carlsbad, so it's nice to see him. Jeffrey is the VP of Data Science, Engineering, and Platform with teams of data scientists, data engineers, and software engineers working for him. Before joining Walmart Global Tech, Jeffrey was the Chief Data Scientist and Global Head of Data Science at AllianceBernstein, a global investment management research firm that managed over $550 billion in assets. At AllianceBernstein, he built and led the data science organization, working with investment teams, sales and client teams, sell-side research, and institutional client teams. Prior to that, he was VP of Data Science at Silicon Valley Data Science, a boutique data science and engineering consulting firm where he led a team of PhD computer scientists, statisticians, and other scientists, helping global communities transform their business using machine learning and modern data technology. That organization was eventually acquired by Apple. Prior to that, he had various quantitative research and modeling leadership positions at places like Charles Schwab, KPMG, and Moody's Analytics. Jeffrey also teaches currently at UC Berkeley, and in the past he has taught economics, econometrics, machine learning, and statistics at universities such as University of Pennsylvania, Cornell Tech, NYU, and Virginia Tech. He is frequently invited to speak at national and international conferences on data science, technology, and artificial intelligence. By way of training, Jeffrey is an applied econometrician with a PhD and master's, an MA in economics from the University of Pennsylvania, and his bachelor's in mathematics and economics from UCLA. So from all of us at Viasat and on behalf of the audience, please take it away, Jeffrey.
Hey, thank you so much. Can you hear me okay?
Yes.
Okay. Very happy to be here, and I first need to apologize first. I had my second COVID shot 2 days ago, and I got really, really sick. And today I still am very, very dizzy and have this massive headache. So I'm hoping that my talk will be coherent, and I'll try to go slow. Really, it's very happy to be here because UCSD is definitely one of the schools that I'm most aspiring to, because I study econometrics, and back in the day, they have so many famous econometricians. And when I study econometrics in undergrad and graduate school, I studied so many of their work. So very happy to be able to speaking to this group. And I also listened to many of the talks earlier this morning in my bed. And many of the advices, as well as suggestions and presentations given, they're all on the point. Couldn't really do a better job than that. So what I'm going to talk about later today, actually today, is the following. Let me share my screen, and when I share my screen, I'm going to shut down my video, and I'll turn it back on in the Q&A sections. So, I titled the talk today is Data Science and AI in Our Daily Lives, a use case of deep learning models. So the agenda is I separate this into a few sections. I first just want to talk about data science and AI that we actually experience on our day-to-day living, and you actually hear many of these applications earlier today. Actually, I should have known what was covered before me before I snapped this deck together. Feel a little bit shameful now. Second is that I spent more than a decade in the finance industry, so I want to go at least a step deeper. Since I have 45 minutes to talk a little bit about neural network, specifically used in forecasting and financial time series forecasting. And I want to sketch one class of the models that is being used a lot in the industry, including many of the applications that we see in section 1, right? If I have enough time, if I don't talk too much, then I'll talk a little bit about data science lifecycle modeling used in the industry. Now, unfortunately, I won't be able to talk too much about what I do at Walmart because of the NDA that I signed with them. And this talk, I didn't get approved by the legal. And so this will be a very generic talk, and I won't be able to tell you, hey, exactly what models I use, what platform I use within Walmart Labs. Lastly, is Q&A. I think we can consider this as part of a first class of the last sections of kind of like a deep learning or an AI course that I would give at a university. And typically, I separate the course into 3 different parts. And the last part would be talking about data that has temporal dependency. Okay. So data science in daily life. So example, there are numerous examples, and some of those I will go a little bit deeper into that. Search engine. All of us use some kind of search engine today, and they actually use a lot of machine learning algorithm or deep learning algorithms within that, both drawing from natural language processing and computer vision. You actually saw a lot of those applications earlier today in many of the speakers' talks. Productivity tools, right? Even things like Gmail or Microsoft Offices. Advertising, right? Have you ever go to a search engine, search, I don't know, let's say, fitness equipment, and then later on you go to another website, let's say weather.com, and then you saw what you just searched in another website. Cars, right? Most of them drive, if not all of us, and actually these days, car have a lot of those so-called AI technology or assisted technology built in to help us drive better, and in some cases, maybe hopefully trying to reduce the number of accidents that we have on the road. Again, I will go a little bit deeper into some of these examples. Smart home, right? Alexa, Google Home, thermometer. Insurance. Insurance actually use a lot of machine learning algorithms. Fashions, healthcare, and retail. So let's dive into some of this, right? So smart home, I myself have Alexa and Google Home so that they don't get too lonely and they can talk to each other. Actually, many of them are backed by many of the natural language processing models, which based on these days called transformers, and is highly related to the LSTM model that I'm going to talk about, using to help answering some of the questions that we have. Same thing for Google Home, same thing for the Apple HomePod. I'm sure many of you have some of these devices at home, and it's actually very, very convenient. In terms of automobiles, right? So in the stop and go traffic, for example, the traffic jam assistant monitors the road ahead and steering the assist control and automatically maintain a safe distance behind the car and in front of us, right? So accelerating and decelerating as traffic allows at a steady speed. And many of the car, like for example, the one that I have right now, would actually keep me inside the lane. If I don't have a blinker, let's say moving to the right, it's actually very hard, at least for my car, to go out of my same lane, right? So these actually use the computer vision technology to detect the object either in front of you or the line that you should be in. This particular example I actually get from the Hyundai website. Gmail. I use Gmail a lot, and probably many of you do. So I'm going to show you an example. This is actually Smart Compose, meaning they before you type, it gives you a suggestions, and you just need to use the tab complete to accept the suggestion. So I'm going to click the link here and link us to the website that show this. So for example, here, right? So Taco Tuesday, and you let's say you get an email from Jacqueline Brusky. And right at the beginning, Gmail will show you, hey, Jacqueline, right? So it was able to detect who is sending you the email and expect what would you type right at the beginning. In fact, this is not just that. As you actually type the email, it actually provides a lot of the recommendations to finish the sentence for you. I mean, these days when I write email, I probably write maybe 1/3 of those, and the second two-thirds I just press tab complete to complete that. Another one is Microsoft Office. So offices actually have getting smarter and smarter and smarter over time. I'm not going to go through everything that they have, but one of those that I find it quite interesting is the following. So for example, if we insert an image into a PowerPoint, so in this particular case, a desk in front of the bookcases, they have this assisted technology that can help say people with impaired visions, right? So they may not be able to see the image that well. So what they have is the following, and I'm going to show a very small demo. Let me minimize this. Right, so on my desktop, I have a few images here, desk 2, desk 3. So I'm going to insert this, and I'm going to show you, again, I normally don't do this. I find this out myself when I'm doing the research for this presentation. So one example, so let's say I want to insert an image, right? So I insert an image from my desktop. And so let's say I want to insert desk, right? So as I get in here, right, it may be hard for some people to see, but if you say, I want to go to the alt text features, right, it actually automatically populate and be able to recognize that this is a desk containing text, indoor computer, and table. Right? I didn't type this, by the way, even though this is not the first time I insert. I didn't type it, right? So now let's try another one. Let's try another one and see how it goes. Because I have one that is maybe challenging and I haven't tried before. So let's test this out, right? So this one. So this one, again, is a picture containing text, floor, and indoor table. Again, it automatically be able to recognize what the image is and then describe it using a text, right? Last one, since I live in San Diego and I surf a lot, not today though. Let's try, let's say this guy right here. This is a Rusty surfboard. This board is actually called SD, stand for San Diego. So let's see what it does in terms of the text. Now this one, they actually couldn't recognize it. It just say it's a diagram. Description automatically generated with low confidence, right? So it was telling you it's an image, but the PowerPoint couldn't recognize this with high confidence, right? So that's that. It's one of those, again, it's using for sure at least some sort of computer vision algorithm to be able to detect these kind of features. I find it really cool. Okay. Next one is, so for skin lesions detections using machine learning. It's an example, right? In fact, Chromacode earlier today have a very great presentations. So here is just one example of how machine learning and deep learning, in particular in this case, are used to detect skin cancer. And so there are numerous use cases in healthcare, right? Ranging from diagnosis, prognosis, treatment, patient communication, and many other use cases. This specific example is the one that used deep learning to create skin cancer diagnosis algorithm, and each type of skin lesions as an assigned class. Now, the algorithm used a version of deep learning called convolutional neural network, which has become really, really popular machine learning algorithm to perform a wide range of computer vision tasks, such as image classifications. It got really, really popular since the competition in 2012 of ImageNet. Now, in this case, what it does is that the first step is to use a digital, insert a digital macroscopic or thermoscopic images labeled with the ground truth. So some human being probably labeled this before. And then these images are being processed and used as input to the convolutional neural network, or CNN. And then multiple layers of convolutional layers are actually used to extract different features, such as edges, corners, shape, and also high-level features, such as the type of skin lesions from the image. And then create what in the field called the image map. And then from the image, again, which are nothing more than a multidimensional arrays of numbers which represent pixels in the image. Then in the final stage, it goes through a deep learning classifier in order to classify different pattern of the image into the class of skin lesions. And this is, again, need to give credit to people who does that, is the DermNet NC. Next one is related to search engine. And this is an example coming from Wayfair, and I want to, again, share with you some of the machine learning capability that they use on their search engine. So let me click onto here. So if you go to Wayfair, this is the website that you have. But one of the capability you might have used it. This is a very popular website now, popular online retailer for selling home goods, not just furniture, but all kind of home goods. So one features they have is you can actually search using images, right? So for example, again, I don't have that many example. I go back to my desktop and say, hey, I want to search for a desk, okay? I don't know how to describe it, right? Sometimes it's easier to describe, sometimes it's hard, right? So let's see what it gives. I haven't done it for this particular image. I did it for other images. So I just import the image into the website. Oh, it's 0. Okay, interesting. Nothing show up. So let me try another one. As I said, I haven't done this one before. Let's say this one. Zero search result with photo. Really? Curiously, it works really well, by the way, for all the other images that I use. Let me try this one, right? Let me just try, say, Gothic style decor. Okay, like this one. This one I really like, by the way. Okay, let me just do it in real time. It's always dangerous to do demo in real time. So let me just copy it. Actually, I don't know if it works if I just copied it. Oh, it won't work. So let me go to my, I can do this. I'm actually very surprised that the normal desk didn't show up. There must be something wrong. Sorry, we had trouble processing your picture. Oh, it must be maybe the kind of picture that I upload. But previously, I actually use a lot of the image search. Actually, I was able to find a software that is very similar to this one. I didn't buy it, but that's one of their capability. Another one is Stitch Fix from Fashions. So Stitch Fix, I don't know if you have used it. They're actually very proud of using their data science capability to design clothes for you, right? This is one of the retailers, fashion retailers, that actually do not show you the catalog, right? They get your preference of their clothing, and based on that preference, they recommend clothes for you and deliver to you on a regular time interval, and you can reject and accept what they have. Earlier, I remember there was a questions about reject influence. In their case, reject influence is actually very important, because by rejecting what they recommend, you actually slowly learn about the preference of your consumer. So I just want to show you their website. Their website is actually right here. But they actually describe, if you're interested, and I will share the slide later. Yeah, they actually describe many of their algorithms on their website, or at least at a very, very high level. And this is not just for designing clothes, but also their supply chain and how they get the products from designed all the way to their consumers' homes. Next one. Now, this one is actually Walmart. Even though I said I can't talk too much about Walmart, but because this is in the public, so I don't mind to talk a little bit about it. I'm going to share a video. I don't use GoToWebinar often, so I don't know if the sound will actually show up. But let me click this nevertheless. Right here, I have this.
Jeff, is there any way you could put your computer speaker next to your microphone?
Oh, absolutely. Let me do it again then. Does it work? Does it work?
No. Sarah, is there any way to do computer sound through GoToMeeting? Do you know of?
On Zoom, I do know, but go to
I was
meeting.
asking Sarah, our event manager.
Do we have the volume turned up all the way on the video?
Yeah, that's what I asked him. If he could put it next to his microphone, and I'm not sure it's working. It is, and it's not working.
Okay. The only other thing I can think of would be for him to to go to the audio panel and select a different sound source.
Yeah, it may not be worth. We may not have time for that.
Okay, so
right. Apologies.
Yeah. So let me just show you the video. At least you see how these things work. This is actually called, what you see on the video is actually called the auto scanner. It's actually scanning what the person was telling you is that this auto scanner, let me go a little bit. So what he was trying to tell you guys is that this scanner actually have thousands of sensors on it, and it was able to scan the shelf for all kind of things, both 2D as well as 3D images that we then can use in our machine learning algorithm. So let me just show maybe a little bit more. So sorry about that. And so in fact, in San Diego, we have a store down south, at least last year, you are actually able to see this robot, this auto scanner running around to automatically scan off this shelf to look at so items not available on the shelf, which is a serious problem, right? As a retailer, you want to make sure that you have items available to sell to your customers. And because this scanner are able to scan so much faster than a human can, as it run across the aisle, and an average Walmart is like 3 football field. And so it is a lot more convenient, and not to mention it won't get tired. These things won't get tired as long as it's follow its path. You know, we have incidents where this thing run into the bathroom, and I don't know how it can get into the bathroom, but it was able to scan all the useful images that we need, as you can see here, that we then use as our input to generate all kind of output that may be useful for us to detect whether or not things are out of stock and what is out of stock. Another example, actually earlier today, I think one of the lightning talk, a professor was talking about item to be expired. Well, actually my team also does that. So as you can see, fresh products, produce, meat, bread, they have items, they have very limited shelf life. And they go expire, and before they go expire, we actually have to price them down. And so on the right-hand side here, you see that the machines that print the label. So the question is, how much are you going to price it down? And so my team actually have the entire end-to-end deep learning system that is sitting behind, not running on this machine, obviously, it's running in the cloud, to price it down automatically based on the locations you're talking about, the product you're talking about, how many items you have in stock already, in order to maximize, obviously, some sort of profit margin, and also trying to reduce the waste, right? So as the professor mentioned, waste causes a lot of environmental problem, and we want to sell as many of those as possible while maintaining certain profit margin. So with that, at least I am hoping that it gives us an overview of a lot of the things that we do, either that we do on a day-to-day, or even just behind the scene, that many data science techniques and obviously technology around those techniques are being used to make our life easier and maybe healthier in some cases. So I want to switch gear to talk about deep learning in financial time series forecasting, and mention that, you know, what are some of the recent advances. First of all, using neural network-based models in finance and in many other applications, by the way, is not new. It's not since 2010 for sure. In fact, I have two books right here, actually right next to me, is on finance, is using neural network. You can go to Amazon and search for them. Both of them are published more than 25 years ago, right? And they talk about how neural network models had already been used back then, and not just in stock forecasting, but all kind of financial applications. Earlier today, Scott hosting from Fico, hosting the panel discussion. I'm sure they're using a lot of different applications of machine learning and deep learning in their day-to-day businesses. So again, first of all, this is not new. But what I specifically want to talk about is forecasting. So the research, academic research in this area has been exploding in the last several years. If you just casually do some search, you will find that there are papers literally written on all kinds of asset classes, from equity to fixed income, currency, foreign exchange, commodity prices, and different kind of indexes as well. And not just the United States, but markets in other countries such as Europe, the Asian countries, and many of the emerging markets as well. So this is just one paper, by the way. I'm not cherry picking at all. The results have actually been quite consistent in that some of the models that are being used, for example, LSTM, long short-term memory network, and some of those actually combining using convolutional neural network to extract features before fitting into an LSTM, have been quite successful in terms of forecasting. Now, in this particular example, the author is actually trying to predict a one-step ahead forecast, and this is showing that this 500 days is actually in their testing set using a rolling window, move forward. Sorry, I'm not very articulate. Move forward rolling window for each of the 500 days to validate using three different metrics: the mean absolute error, the root mean square errors, as well as the R square. Again, all in the testing set, and they compare different kind of neural network architecture in terms of the performance of their result. By the way, as I said, this is only one of the papers that I came across, and many of those have different outperformance that they show. So for example, in this case, they show the network on multi-layer perceptron to CNN, basic RNN. Basic RNN is good for understanding recurrent neural network, but it's actually not great when it actually comes to real-world applications. And then LSTM, and then LSTM on top of CNN. And so what they have shown here is that the hybrid method actually performed the best in their evaluation of the stock indexes. So let's sketch the LSTM. As I said, if this were the last part of a deep learning or AI course I would give, typically I reserve the part of neural network, sorry, the part of recurrent neural network to the last several classes. So consider this as kind of like an introduction to wrap everything up. So the question is, why LSTM and its variance? first of all, LSTM is actually created a long time ago by Jürgen Smith-Huber. I actually met him in one of my talks in Europe. He was actually giving the keynote speech, and super funny guy. And his invention and many of his students' inventions actually have been used pretty much everything that we have used these days, as long as it use natural language processing and some sort of time series forecasting. And I only listed a partial list here, which I got from Wikipedia. But I want to set the stage first regarding forecasting, right? So forecasting problems. So what I show here is a time series with the x-axis being the time period and the y-axis being some sort of measurement. So we have some sort of historical period, and we need to define what is the forecast origin. And because when we train the model, when we train the model, we have to pretend that we did not see the future. So a typical just randomly splitting your sample is not going to work here. You cannot scramble the temporal structure in your time series. And so you have then to decide what is the forecast period, and then you produce the forecast, right? Let me just skip that one. And so again, we need to know what is our forecast origin in order to produce what is in the future. Now, so we then have to ask, so with that in mind, we then have to ask, hey, why don't we just use the typical densely connected feed-forward network, right? So now what you typically see of a feed-forward network in this particular graph that I'm showing you with a single output looks something like that. And so we have the input that are denoted by the x's, and then we have a bunch of hidden layers in between, and I'm going to explain those, what they are. And then we have the output, right? Now, feed-forward network have the following characteristics, right? So the perceptrons are arranged in layers, as you can see here, with the first layer being the input and the last layer producing the output. All these middle layers do not connect with the external world, and as a result, they are called hidden. Now, each of these perceptron is just one layer connect to every other perceptron to the next layer. This, by the way, is a characteristics that many other network architecture need to revise or revisit, because it can lead to an exploding number of neurons and the parameters that need to be estimated depending on the use cases that we have, for example, images. And so the information is constantly feeding forward from one layer to the next, and so the result is, that's why it called feed-forward network. If you want to think from a math perspective, this is actually a very large composite functions. Another thing I want to note here is that each of the neurons has no connection with each other in the same network, in the same layer. And so putting it in math, right? So what are those arrows and that are representing? All of those are pointing into directions and fitting through functions that are calculating what is the output in both the intermediate hidden layer as well as the output, right? So for example, in H1, right, it is actually a nonlinear, so-called nonlinear activation functions that are function of all of the input with all this weight and the bias term. They use the term called bias term that are fitting into some sort of activation functions. For example, the ratified linear unit functions or the sigmoid function. And these hidden units in turns will be fitting into actually miss a function symbol here. In this case, I assume this is just actually miss a symbol here. I should have another function, nonlinear function on top of this of the linear combination of all these hidden neurons and the output. So in between, this is what these functions are, right? But what is the problem, right? The problem is that the information does not account for the time ordering, right? I'm treating this as independent. I'm not treating that X1 is before X2, before X3, etc., etc. Input are processed independently, even though in the next layer, they will all go into some hidden variable, right? But X1 do not affect X2 and vice versa. So what I'm saying is that there is no device to keep the past information. And we are not effectively using the structure of the data, the information that are persistent in the data in order to produce the forecast, right? So the network architecture do not have memory built in. So what we would like is that we would like the kind of network architecture that can retain the past information, that can track the so-called state of the world and update the state of the world as the network moves forwards. And this leads us into a recurrent neural network. And I'm going to show you just very basic, the vanilla recurrent neural network called RNN, and why it can precede the information from the past. So if you remember, sorry, let me just backtrack one step. If you remember from this slide, so in each of the activation function, it is only a function of the input in that before it, and the weight, obviously, and then the bias term. So what recurrent neural network has is that not only, and for the sake of simplicity, I assume that B equal to 0 in this case. So what we have is that we still have the activation functions, and each time step, we still have the input for that time step, and then we have the output for that time steps. But we also, in this particular case, that what enter into the hidden layer for time t is that the hidden state from the previous time step. And the hidden state from the previous time step, as you can imagine, is the hidden state is a function, not just the input in the previous time steps, but also the time step, the hidden state from the time step before it as well, right? So HT here is also called the state vector. So for example, if we move forward into one time period where we have time t plus 1, right? So the input will be the xt plus 1. And not just xt plus 1, they will affect ht plus 1, but the ht, which is the previous hidden time step as well. And this is how information can continue to roll forward to affect the quote future, right? But there is a problem with the basic architecture because later on, right, if we have more classes, later on, right, we'll actually talk about some of the limitations. In fact, both the feed forward as well as, both the forward propagation as well as the backward propagations require a lot of matrix multiplications and the nonlinear functions that are applied to those matrix multiplications or those linear functions, and it leads to two major problems. Actually, one is a lot more serious than the other. Is the so-called exploding and vanishing gradient problems that the network, put it in a simple way, the network is not able to learn from the remote past. In fact, he's Jürgen's student. So in fact, back in 1991 in his thesis, he already discussed this problem. And then several years later, they published a paper, a very, very influential paper, the long short-term memory network. strongly recommend. It's a very good read and strongly recommend people to do it. Now, I want to at least sketch this network a little bit, but unfortunately, if I were to go to their paper, this is the graphical presentation that they have, and I think it's very hard for me to sketch anything from this in less than 5 minutes. 20 years later, you think that they will come up with a better graph, and this is the graph that they come up with, which is also hard for me to talk about. So I'm going to use my own language, and this, by the way, is not my work. This is by Christopher Ohlers from Google, and she published a very well-known blog post, well-known, I should say popular blog post that a lot of people cite. But I'm not going to use her stuff. I'm just going to use this to illustrate what I'm going to talk about. So she tried to describe all this so-called LSTM cell and what are the things inside the LSTM cell in order to produce the state vector and the LSTM cell for the next day in order to roll the information forward. Okay, so what I will be talking about is actually focusing on only one cell, and there you go. So LSTM memory cell, and so in the simplest sense, is actually kind of like it still precedes the basic architecture of a recurrent neural network, but oftentimes people stack these layers on top of each other, right? So typically, what people will see when they implement in real world is layers of all this recurrent network, and so I will be focusing on only one of these and going from, say, the first layer from time t minus 1 to time t, so which will expand to a graph like this. So now consider the ht minus 1 still the hidden state from time t minus 1, and then I want to demonstrate how to go from time t minus 1 to time t minus 1 to time t in the hidden state. Now, first of all, from the time t hidden state, it's actually some functions, right? Is the hyperbolic tangent functions of the memory cell in the current state multiply by some sort of functions, which I'm going to explain what that is. Right? So tanh, as I said, is the hyperbolic tangent functions. And so we have the hidden state, we have the memory cell denoted by CD, and the memory cell itself, go through these nonlinear activation functions multiplied by the so-called, they call this gate. Consider the gate as controlling the information flow from one state to the next state. And this particular gate is called output gate, is controlling the output that is going to affect the hidden state at time t. So this sigma here is the sigmoid functions, which is a function of the matrix multiplication, obviously, of the weight matrix, which is a different matrix than other gates I'm going to show you, denoted as the weight of the output. The previous hidden state, remember, recurrent neural network is a function of the previous hidden states, and this the bias term associated with the output gate, right? The memory cell itself is a memory cell of the previous days as well as the memory cell this day. So let me explain. So the memory cell in the current state, current time step, I should say, right, is another nonlinear functions of with a different weight matrix of the, again, the input are the same and the hidden state are the same, and it is multiply, right? The previous state is multiplied by the forget gates, meaning how much information would we like to allow the previous time steps to affect the current time step, right? Another one is how much information we will allow from the current time step, right? So what it is doing is that it avoids the direct multiplications like a vanilla matrix multiplication, like a vanilla recurrent neural network would do, in order to avoid those gradients exploding or vanishing problem. The training obviously is used the backward, still use backward propagations, but it's actually called the backward propagations through time. In fact, the entire LSTM cell can be described in 6 very simple functions. All of these are nothing more than a simple nonlinear activation functions, either 10H or sigmoid functions, which are functions of the matrix multiplications of the previous hidden state value and the current input. Remember, I think one of the earlier panelists mentioned, you need to know the math and you need to know the statistics as your fundamental, and this is what is required to at least have a basic understanding of some of these deep learning algorithm. So again, we have the hidden state at time t, we have the memory cell at time t, we have the so-called candidate memory cell at time t, which information may or may not be allowed to go in, depends on the input gate, and then the 3 gates that controlling the flow of the output and the flow of the input. Okay. I think I'm going to skip this one because I'm already 15 minutes in. So I'm just going to skip this. If I have questions, I'll talk about this later. Again, I want to thank Tech San Diego and UCSD for sponsoring this and organizing this. And that's it. Hope to see you all again soon in person.
I think Nick's going to come back on camera. Nick, are you there? There he is.
Yes. Yes. Thank you for that. So we have some time here for some Q&A. So if you have any questions for Jeffrey, please pop them in. I'm going to go ahead and get started. I think this was a really interesting overview, and I liked at the top of your presentation how you were showing some practical examples of where every one of us is probably interacting. Also, I appreciate that some of the examples you showed were spotlighting BrainCorp, another local company that we all know and love with the forest growers and other sort of autonomous robots. And given that this whole event is really about sort of boosting the local San Diego, the talent pipeline between universities and local companies and sort of the ecosystem and spirit of collaboration we want. What's your take on San Diego with respect to, like, do we have a good data science, sort of talent pool here? How would you summarize, based on your experience locally, what the San Diego data science scene is?
Yeah, it's funny. I'm often being asked these questions, and some people even claim that there is no talent here in San Diego. I was like, I'm in San Diego myself. So there are certainly, well, I mean, San Diego is a very big, in my opinion, I think it's a very big tech hub and has much stronger engineering presence than there is data science present. But there is still a very large pool of data scientists here in San Diego. I just thought that is not enough, though. Not enough for them to work for all the companies. Fico is here. Intuit is here. They have a lot of data scientists based here in San Diego, even though they're actually not based here. They're headquartered in Mountain View. And then, of course, Dexcom, Viacom, and Chromacode. And I think in the same office building that we have, GoPro is there. And I also have met their data science directors. And so there actually are quite a few data science talents here, not to mention UCSD are producing many data science students as well. One thing I have to say, though, is that it's actually not that easy to hire data scientists here in San Diego. And so to address that question, even though we have, I think we have data scientists and data science talents here in San Diego, there's not enough to go around.
And you just mentioned UCSD and other local universities are growing data scientists. We're graduating data science with bachelor's degrees and soon to be MS and PhD. What advice do you have for aspiring data scientists or data science who have just entered the field at a junior level?
Well, I have to. So many of the advices that you and other panelists gave earlier today are completely spot on. So for sure, they need to have very strong fundamentals from their schools. During interview, for sure, people will ask you some of those fundamental questions. But also go into organization with the right expectations. And I think this is one thing we haven't talked too much about today. So no one is going to hand you a nice, clean data set, and all you do is to train the most interesting deep learning network. This is not going to happen. And so having the right expectation, I think, would be a lot better for people who just enter the field, and continue to learn techniques. In fact, some of the techniques that I mentioned, actually I didn't mention them. For example, the NLP techniques that we use was only open sourced a couple of years ago. And so having strong fundamentals will allow you to pick up new techniques relatively quickly when you come to the industry. And I think you and many of the panelists also emphasize the need of communications, being able to understand your business partner as well. Data scientists in any organization, especially Walmart, work extremely closely with the product team, with the business partners, with the engineering teams, and they all speak slightly different languages per se. And so it's very important that you establish a common language and try to understand what is the purpose of building a model to solve a business problem or a scientific problem or a policy problem for that matter. So having strong communication skill cannot be underestimated at all.
Great, thank you. And I've got one more question right now here for you too. It seems like you've worked at a lot of places and industries that were data internally evangelical about relying on data and analysis to inform their business strategy. What do you think it would take for an organization who's now adopting or changing to be much more data driven or data led in their approach?
It's really tough. Actually, even in finance, even though they are used to using data, they're extremely skeptical of using all these so-called alternative data, such as text, social media recommendations, satellite images, etc., and let alone all these machine learning and deep learning algorithm. Again, I don't know the organizations you're talking about, but having strong executive buy-in, I would say, is very important. At least you got to show interest of you at least need to have an open mind to accept that more information is able to help you make the decisions better. I would say if I were to talk to those organizations, start with simple, right? Don't just go straight into something that no one understands, but start with, hey, with this set of data, what kind of basic analytics we can even do in order to help you to have an understanding of your organization's data and help with the decisions that you have. And then slowly add the complexity of the algorithm into those data and even generate predictions. In fact, this is a very similar strategy that I actually use to talk to business partners who have been here for a long time and are extremely resistant to, say, using machine learning, right? But we first need to establish some common understanding and let them realize the value of using data first. And once you have that common understanding, and buy their trust, the conversation will be a lot easier moving forward.
Fantastic. Thank you. Kevin, I see you pop back on, so I'm gonna pass the ball to you. And you're muted. Unfortunately, I can't hear you, Kevin. Kevin?
Kevin, we can't hear you.
Can you hear me now?
Yes.
I'm sorry about that. So, Jeff, great mix of some kind of a broad overview and then some very, very technical aspects of it. So a virtual clap for you as well. Thank you very much. We're coming to the end of Data Science Day, so we had to put a lot went into this. So I do want to thank a couple of people before we leave. First of all, I want to thank, Sarah Spiva, who's our event and marketing manager, who helped everyone with the logistics. Thank you very much. Also, our talent director, Emma Hureyes, the planning committee for Data Science Day, including Brandon Quach, Scott Zoldi, Steve Cogershall, Jordan Levin, Nate Heidsman, Elliot Weiss, and of course our partners. Boy, they were here the entire time. Eric Mion and Monique Casillas. I know Eric was at almost every single meeting. We couldn't do it without him. He's a big help. He's working in the background on Data Science Day. And so this ends Data Science Day for most of us. The students will be participating in an afternoon session sponsored by our friends at Lytics. And just for 1 minute, I'm going to have Emma, just in case we still have students on this part of it, I'm going to introduce Emma Hureyes, ask her to come on camera, really give a 45-second overview of the Jacobs Talent Initiative, and then guide the students over to the other side at 2 o'clock and give them some logistics if they haven't already signed up. Emma, can you come on camera for just a second as we end Data Science Day?
Just give her a quick moment. She is logging in. Okay, so unfortunately, Emma isn't able to currently log in to the webinar, but I wanted to make sure that everybody who is a student attendee knows that they can attend the coffee chat with a data science data scientist session. It starts at 2 p.m. and we will be on Microsoft Teams, where we will be going into breakout rooms so that you'll be able to ask direct questions of the data scientists who have graciously agreed to join us later this afternoon. I'm going to put the Teams link in the chat function to the whole audience, and I just want to make sure that everybody sees it and copies it to their browser for later this afternoon.
Again,
if you have,
yeah, I'm sorry. That's for the students. This is designed for students at 2 o'clock. I didn't mean to cut you off, Sarah. I just wanted to make it clear that it's, this is primarily designed for students and their opportunities to talk directly to a data scientist and ask some of the career questions and some of the other questions that they may have. Sorry we weren't able to bring on Emma. Emma's our person on campus. So she works directly with our UCSD and other university stakeholders to make sure that all the students understand the region as a career destination. And if you're not on her email list, you should be. Let us know, we will. With that, Sarah, unless there's anything else, I am going to officially going to end Data Science Day. Is there anything we missed, Sarah? Anyone I forgot to thank?
No, just want to make sure that we thank all of our speakers and everybody who presented today. Thank you so much for taking time out of your days to speak to us all. And thank you all for joining us and spending time listening to all of these wonderful presentations.
Okay, thank you very much. We'll end the session. Thank you.